All right, everyone, thank you so much for being here today. We're having two internet debate titans, Planet Peterson and MadeByJimbob, here today to debate the topic, is evolution a scientific theory? So we have a pretty easy to follow format here. We're going to do an affirmative introduction, 5 minutes. Planet Peter's taking the affirmative on the question, is evolution a scientific theory? And then on the negative side, we have MadeByJimbob, who's saying, no, it's not a scientific theory. After the 5-minute introductions, we're going to do a cross-examination on both sides. That should be about 30 minutes on both sides. They are welcome to end their cross-examination early if they like. And then the audience question portion will be after we do both cross-examinations. That should be 20 to 30 minutes. In my YouTube, I have a button that you can press that says ask questions for the debaters here. It doesn't cost you anything. It's just a button you can press and plug in your question, and I'll ask all the fair questions. Don't put anything crazy in there, guys. And then on the closings, those will happen after the audience questions. Those should be about 5 minutes each on both sides. Once again, they can give up the remainder of their time if they don't really need more. The rules in this debate are going to be very simple. So do your best to stay on the main topic. Is evolution a scientific theory? The goal of Planet Peterson is going to be to prove that evolution is a scientific theory, and the goal of MadeByJimbob is going to be to prove that evolution is not a scientific theory. There's not going to be over talking during the introductions and closing statements at all, so please, during the introductions and closing statements, allow them to make their statements, right? During the cross-examination, either debater can take back their time if they feel like it's going off into the weeds. I'm not saying they're going to get extra time, but it's just they're allowed to say, hey, let's go back to the topic if they feel like it's going off topic. If the person who has time on cross-examination asks a question, please try to address the question directly and answer the question. Just do your best there. The person whose turn it is on cross-examination is the one asking questions, so please don't go and start asking a bunch of questions during the cross-examination if it's not your turn on the cross-examination. You both have 30 minutes for that. Just keep the over-talking on that to a minimum, and if you have to interject, just please do it in a polite way. Just say, hey, may I jump in, or something like that, right? With that being said, if interruptions or over-talking are constant, moderation abilities may be used to protect either the affirmative or the negative time. So I'm here to help out both Peterson and Jimbob, right? I'm not trying to take sides here. I'm going to do my best to be an unbiased moderator in this debate. Do either of you have any questions before we get started here? Are you all ready to rock and roll? Cool. I'm going to start my timer right now. Eric, you have the initial 5 minutes. It's starting now.
Okay, thank you very much. Thanks, Jimbob, as well, and everybody that came to see. So, I find this topic to be very odd and confusing. I view this the same way I view the current conversation going around, is it the Gulf of Mexico or the Gulf of America? I mean, one person says one thing, and then the entire rest of the world says otherwise. In science, a theory, it's not a guess, it's not speculation, it's a comprehensive, well-substantiated explanation of natural phenomena. It's based on a vast body of evidence, experiments, repeated testing. It's an enormous series of different hypotheses that all converge toward kind of like a unifying framework or a unifying description of reality. That's what theories are. Other scientific theories like germ theory, relativity, they explain how and why things happen in the natural world. And these are taken for granted by virtually everybody except flat earthers. And then creationist types, they pick and choose certain theories that they want to throw out, but at least they're not flat earthers, right? The awkwardness there is that they typically are engaging in the exact same kind of logic and rhetoric that flat earthers are. But we accept scientific theories because they've, again, been tested countless times and they've passed those tests. And evolution fits this description perfectly. It's supported by multiple independent lines of evidence, including evidence across different disciplines like geology and, well, geology is the main one, I suppose. But anyways, we have the fossil record, we have genetics, we have comparative anatomy, we have embryology, and we have much more. And going back to the spirit of how science is done and how scientific theories develop, evolution does make testable predictions. For example, scientists predicted the existence of transitional fossils like Tiktaalik before they were discovered. And it was discovered in a place it was expected to be found, and in a timeline it was expected to be found. That's where physics and geology overlaps and confirms ideas that the evolutionary science proposes. Genetic research, that's also repeatedly confirmed evolutionary relationships that were originally inferred from anatomy and these sort of classification. Is it an exact science? Is it subjective? Is it objective? That's a secondary debate, but there were all these predictions that were made hundreds of years ago for the most part. And evolution, when we learned how to do genetics, it passed all those tests with flying colors. So to claim that evolution isn't a theory, I don't get it. I don't understand how the methodology fundamentally differs in evolution from any other kind of scientific theory. So I don't know what we're going to see today. I really hope that we're not going to hear arguments about how, since evolution occurred in the past, we weren't there to see it, therefore it can't be science. I mean, this is like the equivalent of arguing that the sun used to orbit the Earth, or that the Earth used to orbit the sun in a different direction. And no modern science can say otherwise because you weren't there. Like, we need a witness. I also hope that we're not going to hear arguments that have nothing to do with evolution, but instead are philosophical ideas about knowledge and reality. That would be a little bit unfortunate, but it also has literally nothing to do with evolution. So if Jim Bob believes that there are scientific theories, then what I think he needs to do is tell us about the methodological approach to evolution and how it fundamentally differs from any other kind of scientific theory. And arguments such as, under evolution, you don't decide what facts are true, so you can't decide what to believe or anything. That's a complete non-starter. That's the case with any kind of science. That's the case with atomic theory. But I don't think that Jim Bob believes that somebody who believes atoms exist can't know anything, because if atomic theory is true, then that means blank. You can believe in other things as well as, evolution. So I'm not going to entertain that diversion. I'm not stupid enough to fall for it. So that's my opening statement.
Perfect. There are 20 seconds remaining. We'll go ahead and reset this.
And this is my cat.
Oh, nice. Jim Bob, I'm resetting this now. Go ahead and do your intro whenever you're ready.
Okay, thank you, Breakfast Tacos, and Eric for coming to the debate and organizing it, Breakfast Tacos. Okay, scientific theory is a likely explanation of what causes an observable natural phenomenon based on an experiment using the scientific method. The scientific method goes as follows. Observation, question is what causes Y phenomenon. Hypothesis is I think X causes Y phenomenon. Experiment, introduce X, remove X, repeat, draw a conclusion, and develop a scientific theory at the tail end of that process. The only arbiter for two competing hypotheses in natural science is an experiment. Evolution is claimed to be a scientific theory in natural science. So what is evolution? Roughly speaking, the process by which different kinds of living organisms are thought to have developed and diversified from early forms during the history of the Earth. The observation in this statement is variation of organisms. The assumed cause, I'm going to let my opponent tell us what he thinks that is. My argument today is pretty simple. Premise 1, a scientific theory is the product of the scientific method. Premise 2, evolution cannot be run through the scientific method. Conclusion, evolution is not a valid scientific theory. There's a famous mathematician and astronomer who said the following in regards to astronomy, which I also think applies to evolution. He said, as far as hypotheses is concerned, let no one expect anything certain from astronomy which cannot furnish it, lest he accept as the truth ideas conceived for another purpose, and depart from this study a greater fool than when he entered. The reason I find this comparable is the inaccessibility of introducing viable hypotheses out there in space is similar to evolution's inability to test viable hypotheses in the grand scheme of time itself, which it requires. This essentially is the argument against evolution being a proper scientific theory. Evolution cannot produce a viable hypothesis which can be taken through the scientific method. Scientific theories are the product of the scientific method. They are not the beginning of the scientific method. So my opponent is tasked today with something that should be fairly simple from his view, which is to take evolution through the scientific method from observation to theory and every step in between. We can start right now, and I'll concede the rest of my time by giving my opponent the opportunity to present his observation.
Perfect. I'm turning this off real fast. So we'll begin the crosstalk then, or the cross-examination then?
Sure thing. So just to quickly comment on what you said at the end there, during a cross-examination, I'm not like producing, like I'm the one asking the questions. So I'm happy to do what you just said there, but that would have to.
That's fine. Yeah, I actually wasn't aware of that when I said that. But yeah.
That's fine. So I'm happy to do that, but you will ask me those questions during your cross-examination. Sure. That's how that'll go. Okay. Anyways, so cross-examination timer that already start, Taco? Yeah, I'm ready. Okay. So Jimbob, is it your opinion that science is capable and pretty good at discovering accurate information regarding the natural world?
It's my opinion that the scientific method can produce high likelihoods of explanations for causal relations to phenomenons.
I agree. I mean, I would take that as a yes to my question. It doesn't deal in absolutes. Go ahead.
Can you repeat your question, and I'll delineate my answer, why my answer kind of reformats the question necessarily. Yeah.
Sure thing. Is it your opinion that science is capable and generally very good at discovering accurate information regarding the natural world?
I would say, no, the scientific method assumes accurate information, then it can do experiment. I would say science, the method, isn't actually required to ascertain accurate information of the world. For instance, I can go out and do proper taxonomy of trees and animals and things just by classification and identity, and be able to come to some good knowledge based on what things are. And so that's a description of what something is. I hold that the scientific method gives us an explanation of what causes a phenomenon we see.
Yeah, and do you think so? What you kind of said there was, well, there are other ways of ascertaining true knowledge. Like if I am hungry, I am not using scientific knowledge. I'm aware that I am hungry. You're wearing a red hat. I'm not using the scientific method so that was the first thing I kind of heard from you, and I totally agree. But what I'd like to know is, for example, you can't observe atoms, but we have a robust scientific framework that tells us that atoms exist and their properties of them. So I'm not talking specifically, I'm talking generically. I just use that as an example. So do you think that science is capable and very good at discovering accurate information about the natural world?
The scientific method, I would say, is not doing that, which is what's in question. If you're referring to science colloquially as a body of knowledge, then I would grant that. Specifically, I'm referring today to the scientific method.
Okay, so if this is like too much of a meta conversation, then that's fine. But what is it that you think the scientific method is not doing here, or is not good at, or is not capable of?
Making its way through. You mean in regards to evolution?
No, just in regards to the scientific method, because I'm asking just a generic question about the scientific method and being able to declare with confidence that these are true things about the natural world.
Gotcha. Yeah, scientific method doesn't produce truth claims, for one. It assumes truth claims. So we start with assumptions about the world. We assume that they're regular. We call them things. These are first order statements about the world. Scientific method is actually looking at a phenomenon in the world that's natural and asking a question of causality, and that's what the scientific method is. The scientific method doesn't actually produce truth statements. It produces likelihood statements about causality.
Yeah, but I'm pretty sure you're conceding that the scientific method is a good method that gets us to drawing conclusions about what we think is what we
see.
think are the best explanations for what's happening.
Yes, causally. Yeah, I agree with
Sure.
that. Causally, but not what something is, right? The scientific method doesn't tell us what something is, right? We declare what something is and we properly categorize, and then we go, oh, like for instance, the scientific method. If I watched, if me and you were on like a hike and we saw bubbling water out of the hot springs, right? You and I would both go, that's bubbling water, right?
I would hope so. Yeah.
Yeah, but you wouldn't agree that we're doing science right there, right?
No.
Scientific
Yeah.
method.
I talked about
Okay.
this already.
Okay. Yeah, that's the distinction I'm making.
Okay. That's fine. My next question would be, which scientific ideas do you reject and why?
Scientific ideas. I'm not sure what you're referring to. What's a scientific idea? Like, give me an example of a scientific idea.
That the Earth is a sphere and orbits the sun, that evolution by natural selection occurs. We know that you disagree with that one, but I'm trying to figure out where else you may be coming from with regard to science and what it claims.
Again, I would reject the category. I would say descriptions of reality. I wouldn't call them scientific ideas.
So nobody directly observes that atoms exist. The only way I don't think you can really argue that we philosophized our way or we speculated our way into atoms existing. There were ideas about atoms going back a very long way to people like Democritus, but we never actually got to the point where we can say with confidence that they do exist and these are their properties until we were doing science.
Again, determining what something is and observing it, I would say what you just said is an observation of something at higher resolution, given the technology improved. So what you're really referring to is an observation. But in regards to theoretics and examining and how to properly frame what it is you're looking at, I believe both categorizing the natural world and describing it and doing science require some assumptions about philosophy, about what we're looking at. Given there's a philosophy of science, I think a philosophy precedes all descriptions as well, and I don't think that's too controversial.
So I'm trying to ask if there are scientific ideas you reject, and you kind of say that I reject that science has anything to say about what is or what is not true, but I would say
Scientific method.
It supports like what is likely to be true. However, I'm pretty sure that there are all kinds of things you agree are true statements about the world that we couldn't know if it weren't for science. Like, for example, that radio waves exist, that atoms exist. So I feel like it's not exactly a contradiction, but I think I don't know. It doesn't seem coherent.
Eric, do you agree that there's a difference between describing something in the natural world and doing the scientific method?
Yeah, but the point I'm trying to make is we arrive there by doing the scientific method. There are some cases where we need the scientific method to be able to do that.
No, hold on a second. We need the scientific method. Okay, wait. So first, the question was, do you agree that there's a distinction between describing the natural world and doing the scientific method? You said yes. Then you said you need the scientific method to get there. Can you tell me where there is you're referring to?
To being able to make make statements or have knowledge about the world.
No, I would say in order to make statements about the world, what you need is the assumption of the regularity of the world itself. You need minds, you need language, and you need descriptions. Mm-hmm. Math could be involved descriptively. Yes. And we agreed. If you and I were walking on a path and I pointed to bubbling water, you agreed that us both pointing to bubbling water is not doing the scientific method. So now it sounds like you're contradicting.
No, because I'll explain it again. There are some things, like the existence of radio waves, that kind of knowledge can only be revealed to us if we go through the scientific method, because it's not directly observable. I mean, the way we observed it was by doing science, but you need that specific framework in order to investigate it. So that's the issue I'm having with this.
Is there a difference?
I don't think science is how you do that. Yet I think that there are many things you think are facts about the world that we couldn't know unless we went through the scientific method.
Yeah, well, again, you're assuming that scientific method produces facts in that statement, and it doesn't. So if we agree that it's a fact that there's bubbling water, and we both, without going into high-tier meta-philosophy, if we both agree there's bubbling water, that statement itself wasn't produced by the scientific method. So the question is, well, what can be produced as a likely explanation of that observation? I would look at you and say, Eric, what do you think causes that bubbling water? That question would lead us into the scientific method, and we can actually investigate what causes the bubbling water. But that there's bubbling water is not a question of the scientific method.
Yes, but that's just so not what I'm asking, and I don't really know how to
ask it again.
There are certain things about the natural world that I think require going through the scientific method in order to know them, because there are things that are not directly observable through our natural born senses, for example. So the scientific method is the process by which we accumulate that kind of knowledge. But I feel like you're just kind of rejecting that at the same time, because, well, yeah, but you need to assume certain things to do science. Yes, but that's not the point. And you have to have an observer and a mind to do. Yes, but that's not the point. The point is,
can I try to rephrase what your question is for you?
Yeah, go ahead.
Are you asking me, are there certain facts we come to know that we couldn't know without the scientific method?
More or less, yeah.
Okay. Does the scientific method produce facts?
I would say it helps us discover the facts that are there.
Hold on. Let me do it again. If you're asking the question, Jimbob, are there facts about the world that you couldn't otherwise not know without the scientific method? And I asked you, does the scientific method produce facts? What is the answer, yes or no?
The answer is, I would say no, but I would say more so like not exactly.
So that means your question has to be malformed, because in your question, it assumes that the scientific method could produce facts, right?
No, because I've been saying that there are things we only come to know by doing the scientific method.
Okay, when you say things we come to know, are you referring to facts?
You could call them this. Here, I gotta reclaim my time. I gotta reclaim my time here. We're at 11 and a half minutes, and we haven't talked about evolution yet, because I'm just trying to understand like how we approach collecting information through science. I don't want to have a meta narrative about philosophical stuff, so I'm just going to use my time to try to get back on track here. Which means I probably don't want to ask question number 3, but maybe we'll get to it. So, Jimbob, if evolution was true, what would the evidence look like?
If evolution was a scientific theory, that's what's in question. It wouldn't, if it were true, it wouldn't be a theory, because theories aren't true. Theories are likely explanations of causal relationships between variables and phenomenon. So again, your question assumes
what we mean
something.
by true.
Well, no, because things that we call facts, for instance, that heat goes from hot to cold, right? We call that a fact, right?
Yeah.
Okay. Heat goes from hot to cold. Pressure goes from high to low. Okay, these are things we call true facts. We call them lawful. Science doesn't come to a theory and it never calls it true, or otherwise it would be a law.
No.
Yes. Are scientific theories true? Yes or no?
They are true. They are true descriptions about the world. I know that you think this because you think atoms exist, and it's called atomic theory.
No, hold on. Are scientific theories descriptions about the world?
Jimbo, you're not cross-examining me here. So,
well, I'm clarifying, because you're misinterpreting two things. Your question assumes that the scientific method, for one, produces theories, which is true, but to call theories true is a mistake. Theories aren't true. They're inductive conclusions about causality, explanation, not descriptions. So there's a difference between descriptions and
that's how we understand. That is very much in the common sense of how people understand statement, like truthness about statements.
Okay.
So anyways, I'm just going to ask the same question again. If evolution did happen, and by the way, that evolution occurs, it kind of is a law because we always observe genetic changes in every single generation, but we won't get bogged down with that. But if evolution did occur, what would the evidence look like?
And can you define what evolution is to know that it occurred for me?
Well, you could, in one sense, say any change in allele frequencies over generations, but the grand question with evolution is that all life on this planet is the descendant of a common ancestor. You can narrow it down more and just say these selective groups of organisms have a particular common ancestor that doesn't go all the way back to the earliest life on our planet, but only goes back so many thousands, millions years or whatever.
Gotcha. Okay, so because the debate topic isn't whether or not I think evolution is true, the debate topic is whether or not evolution is a scientific theory. And so if you're asking me if evolution was a scientific theory, what would it look like to you? What would
No,
convince
I'm
you
just
that it was
asking that
scientific
if evolution happened, what would the evidence look like?
If evolution occurred in the grand scheme of things, I actually have no idea what it would look like because I'm not sure what you're claiming is causing why the phenomenon. So, if someone said, there's a scientific theory I have that this process occurred and produced this observation we call diversity in life, I'm going to ask a question. Interesting. Can you isolate what you think is causing the diversity of life such that you can run it?
You can save that for your cross-examination.
Well, that's what I'm saying. It's
Question,
like your question has nothing to do with the scientific method.
I would
You're
disagree.
asking a philosophical question.
No, we're trying to get.
I thought
there.
you didn't want to do philosophy.
We're not. So I'm confused as to if you don't even know how to delineate the data that would say these evolutionary ideas are true or false. Why is it that you're claiming that evolution is not a scientific theory? And I know you also don't believe in evolution either. So why either of those things?
The topic of the debate is whether or not evolution is a scientific theory. The question of what
you don't know what kind of data that theory would produce.
Data, I'm not interested in data because the scientific method
JimBob,
is more
stop,
than
please.
data.
So you don't know what the data that would be produced by that body of knowledge that is the scientific theory would even be. So I'm curious as to why you think that it's not when you seem to be ignorant about how you would even ascertain whether or not it is.
Well, because if you say, if evolution was true, what do you think it would look like? What would the evidence look like? I'm asking, what are you claiming is actually occurring, such that I'm asking myself the question: did this happen? This is a question of
I know that you know
right?
what evolution is. I'm not gonna spell it out here for you. A scientific theory is going to consist of a very large body of knowledge that's been collected by going through the scientific method. There's no way that you disagree with that. So if evolution was true, what would that body of knowledge within the theory look like?
It would look like starting with an observation and taking evolution down the scientific method steps and arriving at a theory. That's what it would look like for me. That's why we're here debating it.
You're describing the process, not what is the data that would either confirm this idea or allow us to be able to throw this idea out. I need to know what the data would be.
We don't confirm scientific theories with data. We confirm them with
we
experiments.
Absolutely do.
Oh, we
confirm what is it that the experiments give us to be able to draw conclusions?
Fine, fair enough, but I'm not just looking at data without an experiment. So take us through the scientific method.
No. Again, that was part of like what you want me to be able to do for this, but that's not, you don't get to tell me what I do during my cross-examination. I'm more than happy to do that when it's your turn. So I'm just going to ask the exact same question again.
I'm asking for the data.
I'm going to
the tail end of the scientific method. That's what I'm asking for. If you give me the data at the end of the scientific method, I will then interact with it.
You can ask that in the crosstalk portion that you're in charge of, JimBob.
Sorry, go ahead.
Yeah. So I'll ask it one more time, and then I think I know maybe a different direction we can go. If evolution was a scientific theory, then it would possess a collective body of knowledge that supports the theory. What kind of knowledge would the evolutionary theory contain within it?
What kind of knowledge would the scientific...
What sorts of data would confirm evolution and be part of its theory?
What types of data it would include is introduced causal mechanism that produces the phenomenon that's observed. It would include that data.
Okay, so I guess that's what we're going to have to go with. I don't really understand. Do you agree or disagree that if evolution is true, then it would mean that all life on the planet is related?
If the theory of evolution were true, then assuming that organisms are related still doesn't give you the process of speciation as some sort of mechanistic causal.
That's fine. That's not required to know that organisms are related or to be able to test whether or not they are related. But it's very clearly an implication of evolutionary theory that all organisms on this planet would be related.
If you're just saying all life has similar chemistry observably, and all life is bound to similar laws of physics and chemistry,
that's nowhere close to where I'm going with this.
I'm saying relatedness, I'm just saying, from
I'm talking about genetics. I'm talking about Darwin proposed that there must be a hereditary molecule, and that would be passed down from organism to organism. And that is what is responsible for the traits that organisms have. Okay. And the modification of that genetic molecule is what would cause variations in populations. And so it would change over time. Then he had ideas about what it could be. He called them gemmucules or something like that. We know he was wrong, but we now know about genetics. And so anyways, go ahead.
So I'm just I'm going to ask you, when you talk about similar, you're talking about when you say related, you're talking about similar genetic structure, right? Physical?
Yep.
Okay. So
does all life on the planet have that?
If you assumed that we're related because we all have similar material in us, how would you determine that we're not related, but we had similar material in us?
Again, you're not the one doing the cross-examination now.
Well, your question assumes this, though.
That's how science works. Science is predicated on we take assumptions and then we go and test them.
Okay, so let me ask you.
The way you stated that earlier was you kind of got it backwards. We actually didn't know how to test genetic similarities scientifically. I mean, we knew how to do it statistically within a species. Gregor Mendel unveiled that for us, but we didn't know how to really deep down scientifically test the relatedness between organisms. We could see how closely related you and I are, or we could see is there a relationship between species. Now we do know how to do that. It was predicted, so evolution could have failed the prediction that all life on this planet would be related. And in addition to that, it predicted certain degrees of relatedness between organisms. We should be most closely related to the great apes, and then we should be more closely related to all mammals in general than to any other kind of life on this planet. Literally all of those tests have passed. So how do you reconcile the data that confirmed what evolutionary scientists thought would happen?
I would reconcile it by calling it confirmation bias, because the question I just asked shows that it is. How would you determine any organism wasn't related to another organism?
If they shared 0 genes, so that would be how it would work.
So is everything related?
That's not the case.
Is everything related?
You're going to have to save that for your time. I only have 7 minutes left here.
What I'm saying is that the assumption here is that everything's related because of similar structure, and everything has...
The assumption was that everything is related. That was the original claim, and then we figured out scientifically how you test that. and it confirmed it. And now you're
Right.
sitting here saying, "Oh, just
Yeah.
because they share genes, that means they're related."
No, that's
that
literally begging
was
the
how
question.
we confirmed the idea.
begging
And
the
now you're
question.
saying, "Well,
Question
no,
begging.
it's not."
Yeah, it is. I'll give you it.
No,
Premise one.
Jim Bob, it's
Premise
not.
one. Premise one.
Jim Bob, stop.
Look.
You can
Premise
do
one.
you can do this when it's
No, I'm
your
not
turn.
cross-examining. I'm not cross-examining. I'm correcting you. Premise
Yes,
one.
but during a
everything's genetic-
cross-examination, I get to
At premise-
decide how my time
Premise
is
one.
used.
Oh, so I don't get to respond to your cross-examination, apparently.
Not if it's not if
gonna
I
let me
deem it
correct
to
you.
be tangential
Okay.
and or
Fine,
not
you deem
related
it.
to what
Right,
we're
right.
talking about.
Well, maybe the moderator can tell me if it's related.
That's
Can I
how-
answer to the question?
That's how a
of genetic
cross-examination
relatedness?
works.
Can I answer
Planet
to it?
Peterson is reclaiming his time, he said, so let's hold that for the cross-examination on your end, and I'll add like 15 seconds.
Sure. So Jim Bob, do you agree that like paleontologists, for example, use data from other scientific fields? They pull on a body of knowledge from other scientific fields and other scientific theories to go and look for fossils that they think are out there and then successfully find those fossils?
They could be, but it's a pretty generic statement. It doesn't tell me what theories they're pulling from and whether or not they're scientific theories or not. They could be just assumptions, and they're workable assumptions, and that gives them the ability to do what they do. But just smuggling in, do you agree that there's this wide, broad scale of scientific theories they're pulling from is pretty ambiguous and pretty nebulous? You know what I mean?
I mean, not really. So, for example, Neil Shubin, he discovered the Tiktaalik fossil. I don't know if you've ever heard about it, but it's basically a fish with limbs, and it's got a lot of other tetrapod-like structures. It's a missing link. It's a transitional form. The evolutionary theory predicted that there should be life started in the oceans. The fossil record is very clear about that, and then gradually moved on to land. So we should find a fish that has a combination of like aquatic traits and then traits that would be conducive for living a terrestrial life. And Tiktaalik has those. They found it on one of the Canadian islands in Nunavut, I think that's called. I don't remember which island they found it on. But they said, look, we're going to look at the geologic we're going to look at the collective body of knowledge from geology to determine what type of rock strata it should be found in. And we're going to pull on radiometric dating information in order to know which time frame we should look at. And then we should be able to find this transitional fossil in this place. They did find it. How is that anything other than a confirmation of what evolution tells us we should expect to find?
Evolution is a claim about process of the morphology within animals. Finding a fossil, by the way you stated is pretty funny because if you started with the assumption that everything is ancestral, and you started with that assumption, and you found a fossil, in this case Tiktaalik, how could it not be a transitional fossil if you started with the assumption that everything's in transition? There's no such thing as a non-transitional fossil, which is question begging.
No, because the transitional fossils have predictable characteristics from them. We should also expect to not be able to find the organisms of the present in the past. And indeed, we don't. So anyways, is that anything other than so evolution said we should find this thing, and then it did find this thing. What is your response to that?
That's starting with a narrative and finding evidence to support your premise one. It tells us nothing about whether or not evolution is a scientific theory.
This would apply for literally everything. Oh, you think the nucleus exists? Well, then the gold foil experiment that confirmed that's
what
just
exists,
confirmation bias.
We already explained this, and I thoroughly made this distinction, is that what exists has nothing to do with ultimately what causes X. I already told you, we agreed that looking at a bubbling thing or a fossil, if we agree that's a fossil, if we agree what things are, we're asking a different question in evolution. We're asking a question about the observation that we see diversity in life. We're asking a question, what causes diversity in life? That's the question, right?
Again,
that has to run through the scientific method. Finding a fossil doesn't tell you.
Red herring. This is a complete red herring. Yes, because we could apply it to anything that's scientific
what
that
to
you
anything?
believe in. For example, do you think protons and neutrons exist?
I'm not sure. I didn't observe them directly. But
Do
I
you
understand the theoretical framework and why the framework works in
Do you
examining.
accept it, or do you reject the theoretical framework that
I've
claims
never
that
seen
protons
I've
and
never
neutrons
seen the
exist?
observation. So if I saw one, I would be convinced that those things exist. But I've just not looked into it.
Are you
I'm
agnostic
ignorant.
about the existence of protons and neutrons,
I'm
or
a-
do you hold that
Yeah,
I'm
I'm-
pretty confident that they exist?
I am unsure of these things existing as a physical thing, as opposed to a very workable, basically framework for examining the microscopic nature of reality. I don't
Okay,
know. I've never seen it. I'd be convinced, though. I'm telling you right now,
That's
if
fine.
you showed me one
I only have 1
physically,
minute left, so I
and I
just
would
need
be
to
like,
make
oh, okay,
One minute
there it
left
is.
about now.
Yeah, I have a minute left, so I'll just conclude by laying out why what he's been doing here is a complete red herring. Protons and neutrons exist. Virtually nobody has a problem accepting that the scientific body of knowledge tells us that they exist. Nobody has a problem just saying that that is true. We could call it a fact. Now, but an observation that protons and neutrons exist, the experiments like the gold foil experiment that confirms it, well, that doesn't tell you why a proton is positively charged and a neutron is neutrally charged. That tells you nothing about the combination of up and down quarks inside them that gives us its charge. You don't need to know that in order to be able to claim and declare and do science that supports that there are positively charged and neutral subatomic particles.
Why'd you use the word virtually
that is
then?
the end of my time.
Yep, we'll go ahead and call it now. We'll move into Jim Bob's cross-examination. Let me know when you're ready, and I'll go ahead and start the timer.
Okay, I'm ready. Okay,
Starting now.
Eric. Yes. In evolution, in the evolutionary theory, what's the observation?
There are like countless different kinds of observations you could make for evolution.
The best one
Name-
that
name-
you think supports that it's a theory, the best observation you got.
The fossil record and genetics.
Okay, I observed a fossil or a collection of fossil, right? So the observation is fossils, plural, okay? Is the question what causes fossils, plural?
What?
I'm asking you,
let
if
me-
you found fossils, what's the
really-
observation?
Really quick, we don't. So the fossil record was used to build support for evolution, but then there are fossils that were predicted to be out there that we then found. So the fossils are not just observations, and then we form a theory around the observation.
Excuse
The
me, hold on a second.
fossils
Hold
are
on a sec.
the
Stop,
evidence
stop.
that was predicted as well.
Stop for a second.
Mhm.
You just said we use fossils to support the theory. You didn't even get to the theory because you need an observation to get to the theory first. So you're starting with the theory and then you're finding fossils. You have to do it the proper scientific way, which is start with an observation. You don't assume the theory because you didn't get there yet. You have to start with the observation, not tie an observation to your assumed theory. This is not science. This is pseudoscience. So again, if you're going to claim that you found fossils, is there something specific about the fossils you're calling your observation?
Yeah, the characteristics of the fossils. So, for example, Archaeopteryx was predicted to have existed before its fossil was ever found. It should have intermediate traits between theropod dinosaurs and birds, and it does.
Okay, hold on. Again, you're telling a story about the observation. In science, you start with an observation, just purely, and describe it, okay? So what are you purely observing with fossils, please? Very clearly.
The anatomical structure is the most obvious thing you can observe with fossils. And then by observing the anatomical structure of modern living birds and extinct theropod dinosaurs, the prediction that an intermediate fossil form should exist was made. And
hold on. We're not talking about predictions. We're starting with the scientific method. This should be very easy for you. Now focus. The observation is a fossil exists and it shows the phenotype, the anatomy of a certain bird-like creature, and you're comparing that to an observation you have presently with an anatomical similar bird-like creature, correct? That's the observation.
No, I said theropod dinosaurs and modern birds. So what was... Go ahead.
I'm just saying, in clear language, you're discovering a fossil and you're looking at its anatomy and you're comparing it to modern anatomy, right? In short, that's your observation.
Yes, because what evolution tells us is that the organisms of today are the descendants of organisms of the past.
Stop going to the theory. I'm asking. Stop it. I'm asking you.
I'm telling you the scientific steps.
You can't interpret the observation with the theory because the theory is at the tail end of the theory. You have to pretend you don't know what the theory is.
I'm talking. Archaeopteryx was discovered only a few years after On the Origin of Species was published.
I don't care about the story.
Evolution was very much hypothetical at the time, and I'm telling you what happened when it was.
You can't even get to the. We can't even get past observation.
For the modern
Let me ask you. No, stop your story. Stop the filibustering storytelling. I don't care about your stories. Observation. There is a fossil that has an anatomy. There is a current animal today that has similar anatomy, right? All I'm asking you is that the observation?
That's one of the observations. Yeah.
Okay, let's start with that. Thank you. That was really hard. Observation. Old thing has traits, typical traits, anatomy. Current thing has similar things, right? The next question in the scientific method is, what causes the similarity, right? That's your question?
I never asked a question. What are you talking about?
I know, because you didn't do the scientific method. Thank you. So the next question in the scientific method, Peterson, is you start with the observation, and now you're asking a question about the observation in nature, the similarities between these two things. So isn't the question what causes the similarities between these things?
Yeah, and then that would be genetics, which was discovered farther down the road.
Hold on a second. If the question is what causes this phenomenon you call similarity in traits or anatomy, right? Your hypothesis is now this. What causes similarity, correct?
A hypothesis is not a question.
I didn't say it was. We already
Yes,
asked
you
the
did.
question.
You said your hypothesis is what causes similarity.
Dude, holy shit. Your observation
That's what you said.
Dude, the hypothesis is the question is what causes this phenomenon, right? The hypothesis is positing X causes Y, correct?
Yeah.
Okay. So what is X in this scientific method? We got to the observation and we asked the question, what causes the similarities, right? You have fossils and that's your observation, right? A fossil and the current bird that you're referring to. Hypothesis is X causes Y. So what is X?
You could say common descent. You could also say genetics.
Question big. Isn't common descent to the theory itself?
It's an implication of the theory, yes, but we would look at any
common descent is a post-diction basically story of what is occurring. We're asking for something that's X that you could introduce to produce similarities between these two things, right? The phenomenon is similarities in phenotype, right? So now we're asking a question, what causes similarities in phenotype? And you've skipped to common descent, which you can't introduce into an experiment. You can't introduce common descent and remove it. This is not science.
What? We do evolutionary experiments all the time.
I didn't ask if you think we do evolutionary experiments all the time.
I can cite.
I don't care if we do. Right now, we're supposed to be doing one right now, dude. And the observation is similarity in phenotype between an old thing and a new thing. Question: what causes the similarity?
Common descent.
Common descent. So is common descent something you can introduce into an experiment?
Digging up fossils really isn't an experiment, but that doesn't make it not scientific.
That doesn't answer my question. This is cross-examination. Now, please answer the question.
I'm pointing out the red herring.
A red herring? You said X causes Y, okay? Is it correct that you're saying X equals common descent, Y is similarity between these two things?
I'd have to write that down to keep track of it. What I'm telling you is that the reason the Archaeopteryx transitional form exists is because theropod dinosaurs are the common ancestor of
That's begging the
and
question,
modern.
dude.
It's not begging the
yes,
question.
Listen, I'm going to ask you more.
Is
you need to answer my
evolution
question
true?
now.
This is the kind of evidence we would predict.
No,
it was
I'm
found.
not asking for evidence.
Supporting
I'm asking
evidence of
Stop
X.
it. Peterson, stop. This is my cross-examination.
I know.
Observation. We'll do this real slow. Observation. There's an old thing that shares anatomy with a current thing. I ask a question. What causes the similarity? Your hypothesis
it's proposed that common descent causes it. And then we found the evidence that
hold on.
Keep the interrupting to minimum, please.
Stop it. Okay. You posit that a thing called common descent is the independent variable that causes similar anatomy, correct?
There's no independent variable.
I'm asking a question.
And your question is flawed, which is why I'm informing you that doing paleontology doesn't have independent variables because it's not an experiment.
Therefore, it's not science. Now he's insulting.
You don't have... No!
Cross-examine.
Hey, guys, let's not... I lowered the volume for a second. Let's not insult each other in the debate. One at a time, please.
Question. Can you develop a scientific theory without an experiment?
Absolutely.
You can. Okay, so what's the need? Why use experiments then if you could just develop theories without experiments?
Because they help.
They help? Okay, so I can just develop any theory without an experiment and you just believe it because I don't have an experiment to be the arbiter of two competing hypotheses.
There's more. You literally started... You were actually doing this earlier. There's other kinds of evidence, like just mere observations, than experimental evidence, but that doesn't mean that it can't be part of science.
Observations is the first step, dude. I didn't say it's not part of science. I said observation is the first step. Now tell me, how do you arbitrate between two competing viable hypotheses without an experiment?
You can look for evidence like let's say I think that George Washington was actually a woman, and somebody else says I think he was a man.
That's not a scientific question.
We go and dig up his bones. And
it's not even a scientific theory, dude. Not a scientific theory. We're talking scientific theory.
We're talking about how do you delineate information absent an experiment? It can be done.
I didn't ask that.
It can be done.
I did not ask if you can gather information. I asked you, can you develop a rigorous scientific theory without the scientific method? Again, I'll read my opener here. Scientific theory is a likely explanation of what causes an observable natural phenomenon based on an experiment using the scientific method. The scientific method goes as such. Observation. Ask a question. What causes Y? Posit that X causes Y. Introduce X, remove X. Repeat. Conclusion. Develop a scientific theory. Now, I've demonstrated that for your, quote, theory of evolution, when I ask you what's the observation, you say there's this anatomy we found. It looks like this other anatomy we have. Look at the similarities. I ask you, interesting, what causes the similarities? You say common descent. I ask you, can you introduce common descent and remove it? You say no. I say it's not a scientific theory. You say experiments are not necessary for scientific theory. Let's take it down a notch here. Let's say scurvy is a thing.
Can I address that or not?
No. So scurvy is a symptom, right? A set of symptoms. Scurvy.
I would call it a condition. The symptoms. Yeah.
Okay, great. It's a condition. Is it fair in the scientific method inside of natural science to ask the question, what causes scurvy?
Yeah, that's fine.
Okay. Could I arbitrate between two hypotheses of what causes scurvy without an experiment?
It wouldn't necessarily have to be a controlled experiment. You could literally just read ship logs and see, wait a minute, those people on that ship, they took not freeze-dried, but preserved vegetable, fermented cabbage, fermented foods, that was a way to because they didn't have refrigerators. So they could get their dose of vitamin C. Nobody knows what vitamin C is back then. But anyways, you could literally just look at the historical record and you could say, hey, wait a minute, these people were, they had that kind of food. And then this other group of people, all they ate were meat preservatives and crackers and things like that. They got scurvy and then they didn't. That would be supporting evidence. Now, ideally, you would go on to do experiments that help validate.
Hold on. I understand. Peterson, hold on. What you just said is that's an observation, and that's the moment you're actually forming a hypothesis, right? Right. Looks like one ship had oranges and vitamin C and a way to preserve their nutrients, and that ship didn't get scurvy, but this other ship is missing something. That's a question, and I would argue, and I think you would agree, that that's actually where you introduce your hypothesis.
Sure.
Okay, so I'm asking you again, if you have two competing hypotheses, right? Let's say someone else says that's not the case. Is there any way other than an experiment to actually arbitrate between the two competing hypotheses?
Yes, because hundreds and hundreds and actually thousands of ships have sailed, and you could look at the records of all of them. You're not producing the data yourself. You're not doing the experiment.
It's an observation.
But if you say yes, but these are observations that confirm what your hypothesis is. If this is literally how studying the past works. Now we can study evolution in the present, but this is a little bit of a tangent, but other scientific theories like the Big Bang, we don't recreate the Big Bang. We do recreate certain conditions to know some things about the first moments of the Big Bang, but literally all of it is just observations. We did the math.
Just data, dude.
We said there should be these predictable things out there in nature that we see, and we found them.
Hold on. Can false assumptions accurately predict phenomenon?
Seems reasonable that could happen.
Okay, if two different models or hypotheses are saying, look, I'm observing the data and you're observing the data, I think this is causing the phenomenon that's predictable. They both have a predictable element to them. One is true and one's false, or maybe neither are true, right? I'm asking you, if someone's looking at data of thousands of ships, I don't care if it's 1 million ships, and it looks correlative that the ships that have food preservation technology and vitamin C don't get scurvy, and the ones that don't, they do get scurvy. That's an observation. That's data. I'm asking a different question. When we introduce a hypothesis of what causes the phenomenon, is there any other way to arbitrate between two competing hypotheses than an experiment? Your answer was, more data. No, you just said more data. So no, the answer is no, because I just told you two people could have the same wealth of data and posit different hypotheses about the cause of the phenomenon, and one could be wrong or both can be wrong. The question is, how do you determine in natural science who's got the correct hypotheses other than an experiment?
I literally answered this question for you.
More data.
What is it that experiments give us? More data.
Causal. I'm not saying. No, hold on. No, stop. This is sneaky. This is sneaky.
I'm answering your question. The data that is produced from the experiment can absolutely exist in other cases that have already occurred. So there's no meaningful difference. Experiments are great because you can control
Hold on a second.
things.
I want you all to listen to what he just said. The data post-experiment is no different than the data pre-experiment.
That's not at all what I said.
That's literally what you said.
The data that is yielded by an experiment is in no meaningful way different than the exact same kind of data from the exact same type of scenario you would set up with the experiment, but it's already occurred.
Okay, so here's the thing. The question isn't whether or not you call the results and information you gain from an experiment data. That's not what we're talking about, right? We're talking about whether or not pure data without an experiment can give you a likelihood cause. And I'm saying no, and you're saying yes.
That's because you're wrong. I can explain it to you. I can explain it to you.
Can you develop a theory? Can you develop a look, let's do it again. There's a ship that comes in and they're sick. There's a ship that comes in that's not sick. We look at the contents of the ship. We see the one ship that's not sick has all of this stuff, right? Vitamin C, preservation. The other one doesn't. We make a correlation. We go, this is pure data right here. We can actually work with this data, right? I'm asking a different question. Can you develop a scientific theory of what causes the condition, illness, without doing an experiment?
Yes.
So why does science need experiment then?
Okay, let me try to bridge the divide that we have here. I think how this originally started was you were trying to get me to tell you how could you get data to support it without the experiment. Now, 2 ships come in, we make an observation about this ship has a bunch of scurvy, this doesn't. We look at what kind of foods the one ship had, we look at the kind of foods the other ship had. We build a hypothesis that says it's due to these vegetables and fruits or whatever. We don't have to run an experiment to get data that confirms that, because we could literally just watch every single ship that comes in after that point, and we have nothing to do with the way it's set up. Those those kinds of things are sometimes called natural experiments. So you can do all of that without setting up, like in a lab or whatever, the conditions for it.
Okay, got it. So let's say, hold on. No, don't filibuster. Don't filibuster.
Well, no, I was actually going to try to agree with you.
This is okay. Okay, go ahead. I'll let you just good faith. Go ahead.
I will absolutely agree that ideally you would want experiments, like controlled experiments or whatever, because they eliminate a lot of external variables that allow you to laser focus on what you think is happening.
Okay, I'll ask a question. Let's say we didn't know what caused scurvy and there was a grant out with 2 scientists, right? If one scientist was you and one scientist was me, right? And there was a reward for who can develop the scientific theory of what causes scurvy, would you go ahead and present just a correlative argument of the data between ships, what they have and what they don't have, and one clearly correlates to the sickness and one doesn't? Or I do an experiment introducing oranges, introducing and removing oranges and food preservation technology, and I repeat that over and over again. Who's going to get the second grant, me or you?
I don't know.
I am. Why? Because I developed a scientific theory using an experiment, and you didn't develop a scientific theory, and you just merely made a correlative assumption. The difference between a correlative assumption, or let's call it a hypothesis, and another hypothesis is the only arbiter for who's correct in their hypothesis is an experiment.
JimBob, the problem there is you and I are going to have the same data. It's just that you obtained your data in a different way. I'm going to have data that says if they eat fruits and vegetables, they don't get scurvy, and so will you.
Oh, you didn't. You look, the same data that's happening. For instance, let's say, I mean, I couldn't think of a more simple example than this, but I'm going to have to try to think of an even simpler causal example. Let's say poison. Okay, let's say someone's poisoned, and we don't know what caused it. What's the poison, right? You say, well, there's a bunch of poison in this room that's kind of toxic, so it's probably that caused it. And I go, well, there's a variation of poisons here that may have caused it. And you go, yeah, there might be a variation of poisons that caused the death of this person consuming it. You're saying to develop a scientific theory, you don't actually need to introduce the poisons and test which one causes the kind of condition or death. You can just assume, because there's poisons around, that your scientific theory is pure data. There's poisons, and maybe he ingested poisons, right? That's all you're saying, right? We have access to the same data. The problem with your pseudoscience is that the only way to develop a scientific theory, right? Let's look, I'll make it simpler. I choose one poison and you choose another. They're both in the room, right? Peterson goes with this one and I go with this one. I say, oh shit, Peterson, we have competing hypotheses. How are we going to develop a scientific theory of which of the poisons killed this person, right? Can you imagine the coroners taking Planet Peterson's approach to science? Can you imagine that, what that would look like? They don't need to do a scientific experiment to investigate what causes.
In the 1800s. Like literally what you're talking about, John Snow in London in the 1800s did this. He was noticing cholera outbreaks, and what he did was he mapped all the city's wells, and then he mapped where like human waste was being dumped, and then he was able to conclude, or he thought that it was caused by the human waste, and then he mapped out the locations of all the wells in London, and then the locations of where the human waste was being dumped, and they found, look, the cholera outbreaks are happening in these specific spots.
That's correlative data.
Not happening in these other spots.
That's correlative data. That's great and useful. We agree.
what you could do from that point to advance the theory is say, okay, well, why? What causes cholera?
Yeah,
Well,
yeah.
I think that it's not just poop; it's bacteria in the
That's
poop.
right.
So you can
Yeah, now we're
advance
getting
the
somewhere.
theory that way. Yeah.
Well, no,
But
no, that's not
you're
the theory
pretending
yet.
that
No,
you
no,
can't
stop,
get
dude.
the same kind of
Stop.
data.
Oh,
Yeah, I
you
stopped.
just posited the hypothesis. You said advance the theory. No, you don't. Can you get you're basically saying you can get a scientific theory without doing comparing and arbitrating between the two hypotheses. Okay, again, Eric,
Yeah.
we're at a party. It's a murder mystery. There's a death. Peterson says, dude, that shrimp has poison in it. And I go, dude, this other thing, there's a poison bottle right here with a jabber on it, like a little pricker, right? And you go, well, I think the shrimp caused the death. And I go, I think this poison caused the death, right? So the question is, right? The question is, how are we going to arbitrate between your hypothesis, the shrimp caused it, and my hypothesis if we have the same data? There's data. There's shrimp. There's this. There's a dead person. How are we going to arbitrate between the two competing hypotheses?
You could, in real time, have different groups of people eat the shrimp and then collect data that
Is that a scientific experiment?
You could collect data in the
present. Hold on? Is
or
that
you could
what
get
you just
the exact same kind of data by looking at events like this that have already occurred?
Dude, what you just said is feed the rest of the group different things. I agree. Yeah. The two maniacal
There's
scientists.
More than one way.
Hold on. How else? No. You just said the proper way. Introduce the variable X shrimp and variable X1 poison. Inject people with it, and then that's an experiment. And then you could tell what happened, right? I'm saying, how would you know other than doing that? How would you know what caused the death?
Again, you could look at it's kind of weird to call it a historical record in this case, but we could look at like
about 4.5 minutes left, and let's try to keep it all on topic.
This literally does happen. I mean, we're seeing it with outbreaks of avian influenza now, or like with the E. coli outbreak with McDonald's. I mean, we already know that E. coli causes food poisoning, but it's like, well, was it from the lettuce, or actually it was from the onions for McDonald's? Let's track down the onions. Let's track down the farm. Let's track down the distribution. Yeah. Let's look at the cases of people getting sick around the world. We're not performing an experiment, but we're confirming our idea there. Dude, nonetheless.
Look. No.
The experiments are great. It's not the only way.
No, I didn't ask about what you think confirms, because there's two different hypotheses that correlate with the data accurately and accurately predict. If the fact of the matter is two competing hypotheses could both correlatively predict things, we're asking a different question in natural science. You said that E. coli, we know E. coli causes this. Well, that's interesting, because that's a claim of natural science, that E. coli causes this type of sickness, right? We wouldn't know that unless we isolated E. coli and it's causing this. Let's say we didn't know what E. coli was, but we only knew that lettuce seemed to be the correlative agent here. Well, the only way you can develop a scientific theory in regards to the data you have is to investigate what it is that's actually entering the body, introduce it to the body, remove it from the body with two sample sets, do a scientific experiment, and then see what happens. Is it null? Does it verify your hunch that this little microscopic piece of shit went into someone's stomach and caused all this brutality internally? Yes, you can actually introduce it. That's the problem. To tie it back to evolution, observation is fossils in the past look like fossils in the future, or not even fossils. Looks like something in the past. They have similar traits, right? I ask, what causes this? Peterson says, common descent causes this. I say, interesting. How do you introduce common descent and remove it such you know that it's causal to this phenomenon? He says, you can't do that. That's a concession.
No,
you can't introduce and remove common descent.
You can't you can't remove it because you can't change the past.
You can't take it to the scientific method then.
Yes,
new hypothesis, please. No,
we
new
do
hypothesis,
evolutionary. Please. We do evolutionary experiments today.
I didn't ask what you think we do. I'm asking you specifically about this observation.
What kind of
And your
statement is that?
dude, listen to me. Observation, again, there's a thing in the past that looks like a thing in the present. They look similar. The question is, what causes them to look similar? You say a common descent. That's like a category, right? A common descent. This occurs, okay? So how do you introduce common descent and produce the phenomenon, remove common descent, and see if the phenomenon's still there?
1 minute left.
So
really all you're saying is we can't make the course of history.
I asked you a question. Is this cross-examination? Don't tell me what I'm saying. I asked you a direct question. How do you introduce common descent and then remove it to know that it's causing the Y phenomenon?
The idea that because we can't rerun the course of history means that that evolution can't be like a scientific theory.
I didn't ask for a meta. I didn't ask for a meta. I did not ask what you think is stupid. I asked you if you're saying in natural science that common descent causes the Y phenomenon. I asked you a scientific question. How do you introduce the independent variable common descent into a situation and remove it so you know that it's causing the phenomenon of similarities? Just say you can't answer it and go to a new hypothesis, dude. Bite the bullet.
No, well, we could confirm it in different ways. We could test the genetics of archaeopteryx and birds today.
If you want to finish,
and then we could, I'm addressing this thing here. So we could confirm it in the present by testing the genetics of archosaurs living today and birds living today, because that is the data that would be predicted by common descent, and then we find it. So anyways, we're out of time, but we'll see what the audience.
Yeah, let's go ahead and move into the audience questions. I have quite a few in the live chat. If anybody wants to post any in the live chat, it's just on my YouTube at Real Breakfast Tacos. We'll also try to raise some hands here as well. And Jim Bob, if you have anybody in there, just have them pop in there and hit the live.
Can I just announce, unless they don't know, guys, if you do want to go in there, it's the politics Discord, and it's is it pretty obvious? Evolution is a scientific theory down at maybe middle or something.
It'll pull them right in if they look on the top left, and it's just https://www.discord.gg/politics. Everyone should join Discord. It is an awesome server, as you see. We have
everyone join politics server. Tacos helps run it. And there's a lot of new debates coming to this channel. So,
yep. You guys ready for some questions?
Sure.
Cool. Let me go ahead and turn on this timer. I'm setting this for 30 minutes, but if we don't go 30 minutes, it's not a big deal. The first one was Hank of Flamio. Jim Bob, does it matter if we follow the scientific method if we can make technological progress without it?
Yeah, I would separate those two. I'd say we've made technological progress before the scientific method was properly formulated. And maybe Peterson would even agree with me that engineering could appeal to science and natural science and really buttress itself up and make it awesome. But you can certainly do engineering without doing natural science and experimentation. You can fidget around and figure things out. It's on law.
Gotcha. And most of these people in my chat are going to be asking Jim Bob questions. So if you have any guys that want to ask questions, have them pop in real quick and post a question. It doesn't cost anything. It's just questions for the debaters go here. I'll try to split that up the best as I can. But right now it's a lot of Jim Bob questions. Last first name, can we have a comprehensive definition of what counts as evidence? And can they address Popper's critique of evolution? I guess that's to both of y'all. Y'all can address that as you like.
Planet Peterson might be more aware of Popper's criticism. I just think the question itself is, when we look at things, what we call evidence, we're looking through some lens, right? But strictly looking at data and evidence isn't really what's in question today. The scientific method requires supporting evidence, and you're going to look at that, but evidence itself doesn't actually give you the scientific theory. You need to actually do a method to produce a theory. But Peterson, you can answer that if you
want. I just looked up on ChatGPT real quick what Popper's problem with evolution was, and he said evolution was too broad and vast to really like fall under his falsification idea. But apparently he kind of recanted that because he said, well, evolution does testable predictions. So he sort of accepted. What was the other part of this, though? I'm sorry.
But it's evidence.
Yeah, can we have a comprehensive definition of what counts as science, and can you address the critique?
Evidence. Yeah, I would say evidence is just information or data that increases the likelihood of a conjecture.
I would agree with that, and I would say that there's a whole slew of types of evidence. There's a lot of evidence. I forget the number. It's a lot of subcategories of evidence.
Gotcha. This next one is from one of Jim Bob's best friends, B.S. Lewis. He said, would Jim Bob consider a dog coming from a non-dog evidence of a miracle or evolution?
Dog coming from a non-dog?
Correct.
Yeah, I'm not sure. I mean, what's the non-dog? You're saying a wolf?
I think he's saying like a earlier state, but yet possibly a wolf, yeah.
I would need to know what he's talking about. I would just say a wolf would still be in the category that a dog splinters from. I wouldn't say it's doing any sort of jumping of category at all. So no, I wouldn't consider that. I would just call that like a type of crossbreeding, and that's totally fine because we can actually engineer crossbreeding. But it has its limitations. So I think evolution posits a little bit more than whether or not a wolf can sort of dilute or create subcategories of dogs underneath it. I don't think that's in question.
Gotcha. So it's neither evolution or a miracle in your view.
Right.
Gotcha. And then another question for you from Austin Sims. Do you actually believe this matter can or should be settled by a YouTube video or debate? And then they went to answer the question.
I don't know if I would ever say things are settled. Certainly not from amateur debaters like Planet Peterson and myself, who just kind of do this for fun and argue and partly entertaining. But no, I don't know why that question would even apply. Like, I think what settles the matter of science is my opening statement says, Austin Sims, is that the only arbiter for two competing hypotheses in natural science is an experiment. So it's not the debate that settles it. It's actually an experiment that settles it.
Gotcha. And then Kunai asked a question for both of y'all. He wants both of y'all to define what a scientific theory is.
I add this into my opening. Yep. Scientific theory is a likely explanation of what causes an observable natural phenomenon based on an experiment using the scientific method. Scientific method goes as follows. Observation, question, what causes Y phenomenon? Hypothesis, I think X causes Y phenomenon. Experiment, introduce X, remove X, repeat, plot out a conclusion inductively, develop a scientific theory of likelihood.
And Eric?
Yeah, I mean, you can define it in so many different ways. What I typically like to say is that a scientific theory is a collective body of knowledge. Maybe a little bit more specifically, it's a collection of proven hypotheses that all converge toward a unifying explanation for some sort of underlying phenomenon.
Gotcha. Sorry, I had somebody asking to get pulled up, but we'll pull people up here at the tail end of this. I'm going through all the written questions first. I'm also looking at the chat that we have, the debate chat, but I'm not seeing too much in there. The next question was, and this is from Todd Ferguson, Florfament Supervisor, what predictive possibilities does creationism give?
Predictive possibilities. Yes. Well, I wouldn't put creationism in the same category as science and natural science. So I would just say that those are separate categories. But if you wanted to get theological, I would say that if creationism is true, if Christianity is true, we would see a coherent, intelligible universe, which grants humans in particular the capability of doing philosophy, examining the world, making truth statements about the world, engineering, doing a type of creation ourselves at a micro level. Those things I would expect. I would also expect human beings to be, in particular, arguing about morality and goodness in the world and evil, and having a spiritual battle, if you will. So that's completely consistent with what I think a theistic world would produce and predict.
Gotcha. And this one was for both of y'all. It's about the scientific validity of evolution and how y'all are critiquing it or defending it. How many evolution papers have you read? Have either of you published any critical works? And then what is your experience interacting with this scientific literature on the topic? And that's from Aaron.
No, I don't get too far into the literature because what I'm interested in is not what's written about. I'm interested in whether or not there's a viable hypothesis that's brought into the scientific method through experimentation such that X causes Y phenomenon. And I'm looking for those things. I'm not looking for deep, dense reading material, because the only thing I'm interested in is the experiment.
Gotcha. And Eric?
I don't read a lot of scientific papers because a lot of scientific papers contain a lot of like statistical jargon, and people who are much more gifted in mathematics than I am can look at that and just see what it is, but it looks like Greek to me. But I read a lot of papers when I wrote my first book, because there's a very long evolution section in there. So I mean, there's tons and tons of papers from like the National Institutes of Health or whatever. But I've read like, I don't know, a couple dozen books about evolution that, you know, tell you the kinds of information that you get from those experiments and others in a easy to digest way. I did get published in, when I was an undergrad, I got published in my university's research thing or whatever, for some experiments I did on African claw-toed frog tadpoles. It wasn't really necessarily an evolutionary experiment. It was an embryological experiment, but
I would add that both Peterson and myself, among others, even being lowly YouTube talking heads, do a service by, regardless of whether you side with him or me, is that we do pull people into engaging with evolution, such that maybe they will look into papers and stuff. So not like it's moot or it's useless just to have debates if Peterson and I aren't deep diving into like 1,000-page literature studies.
Absolutely. And then this question is for both debaters as well. And it's related to the discussion earlier. Are ethical concerns considered when suggesting that poison ought to be administered to gain data about poisons?
I would say that is, I think the medical field does have a blurry line that I'm not fully, I don't have a full position on, in fact, in regards to how much we test existing humans. Some people extend that to even animals. But I think Peterson and I would both agree that the best way to know what causes phenomenons inside the body in regards to health and conditions would be a direct exposure to the thing itself. We just have to go like, well, how much do we want to do this? What extent?
Right. And Peterson?
with evolution, but
right. And then Baba Ali was asking, Jim Bob, when explaining the motion of the planets with Newton's laws, do we need to add or remove planets to see if it's true and works?
No, because that would just be descriptive. We're not, the question of whether or not X is causing these things might be a good question. Even Copernicus, if you guys heard in my opening statement, said, as far as hypotheses is concerned, let no one expect anything certain from astronomy, which cannot furnish it. I'll just leave it at that. Even Copernicus knew that looking at observations in the sky and being able to even predict the objects in space and how they move to a high degree, like a low margin of error, doesn't actually give you access to causality. So,
gotcha. And then AA batteries had a two-part. Oh, sorry, you can talk.
Yeah, I wanted to add a little bit to that. I wish I would have remembered that because one of the most common flat Earth talking points is there's no independent variable for gravity because like you can't take gravity out to confirm it. So that is the exact same kind of rhetoric, Jimbob, I think you were using. So I am curious, if you accept the theory of gravity, why do you accept it when we can't manipulate gravity as a independent variable?
Yeah, well, first of all, that's genetic fallacy, and it's also well poisoning. The validity of a statement has nothing to do with who else says it, first of all. To gravity, I would call gravity more law than anything. The same way it's a law that heat goes hot to cold and pressure goes high to low and other things. I would say that gravity, the effect, seems to be a law-like effect. When you start to make claims about what causes this effect, you're actually getting into natural science. And I agree with those terrible flat earthers that you are talking about, that you really can't introduce the cause in this scenario. You have to just, which is interesting, is like, why, if something's law-like, why don't you just describe it as law-like? And why double down on the cause if you don't have access to the cause? That's a pseudoscience.
Okay. And then AA Batteries was asking a two-part question. First off, why are fossils not evidence? And then he made the statement, I observe modern birds and theropods, then predict an intermediate species exists if evolution is true. We then find it, the Archaeopteryx. And then he says novel predictions are evidence. So he's just asking, why are fossils not evidence in a case like that?
Because what you call evidence is referring to the theory. But in a scientific theory, you have to get to the theory. You wouldn't even know what it's supportive of, right? So things can support a hypothesis, but the theory is the product of the experiment. And so, again, we're back to square one. The observation is similarity in phenotype and anatomy between something old and something new, which, to my view, if it came up, has more to do with what the function of those organisms were, rather than this claim that one comes from the other. But further, it brings into question, well, what is it evidence for? Well, what it's evidence for has to back what the hypothesis is. But if you can't introduce hypothesis as a variable to produce the phenomenon of similarity, then supportive of nothing, because you can't grab the theory. You can't grab the theory because the theory is at the tail end. You can't start at the hypothesis and then go, this hypothesis supports my theory. No, you have to produce the theory by going through the method. You can't just jump to the theory and put it in step 2 of the scientific method. Ridiculous.
Gotcha. And then Rude Beast was asking, this is for you, Jimbob, and like I said, if any of your audience would like to ask questions, just have them pop in, click the Q&A, questions for debaters, go here. I'd love to have a few more for Planet Peterson too, if possible. But for Jimbob, based on your definition, do you believe the field of astrophysics is a valid scientific field and is able to reach valid conclusions?
If what you mean by conclusions are predictive patterns that are observations, I would say yes. In regards to, is it a proper natural science, I would say no. I agree with Michio Kaku. It's guesswork. It's a lot of theorizing, but not in the scientific, necessarily scientific way. Mathematics are largely useful for predictions. Explaining or describing movements and patterns, but mathematics, which astrophysics largely is descriptive. Science is explanatory, kids.
Gotcha. And then I'm going to skip the personal one. And I had a few people asking. So on the YouTube, there is a Q&A spot for questions for the debaters. Go here. It just helps me stay organized because I have 50 windows open right now. But very hard to sort through everything. But if you do have any more questions there, feel free to put them on there. And then the last one was basically just a repeat of one of the earlier questions. I'll go ahead and pull up Minar. I believe this one was for Planet Peterson. And Minar, please be respectful to the guests.
Yes. Hello. Can you hear me, guys?
Yeah.
Yes. How's everybody?
Unfortunately, we can hear you, Minar.
Jimbob, great to see you today. Sounded great. No, as funny as you usually are. Planet Peterson, horrible job. A horrible job. I hope you do better. You started yelling and shouting at JB. That was the funniest thing. For once, somebody was funnier than JB. But anyways, Taco, thank you for bringing me on. I want to know, Planet Peterson, what's your contention and how do you actually understand? And I want to understand, maybe me, I'm the one that wants to understand how do you actually contend and how are you okay with major biologists being against the idea of evolution? For example, we have major biologists like right here. Her name is Lynn Margulis, and she's actually wrote a complete work against evolution and all of the Darwinism theories. And basically, she tries to expand against evolution through natural selection and says that the natural selection has no power because you need bigger chickens to lay bigger eggs in order for you to get to a different species. It's impossible because when you do get these bigger chickens, turns out they become mutilated, unwell, they're sick. When you actually get to this kind of perfect chicken and you try to perfect the breed,
what is your question?
My question is, what's your contention against major biologists being actually against the theory of Darwinism through natural selection? Let's start there.
We don't use Darwinism today. We have what's called the modern synthesis, which is a combination of Darwin's ideas, but also genetics and a few other things. Lynn Margulis, it's hilarious that you would use her. She doesn't reject evolution. Apparently, she rejected some ideas about like, well, Darwinian evolution doesn't go far enough. She's one of the most important people in confirming the idea of universal common descent among organisms because she was the one who pushed it was completely theoretical. Yeah.
Can I read you something from her? She says,
No,
this is the issue I have with neo-Darwinists.
Taco, I'm answering this guy's question.
Can I just read it for a second? This is what I have with neo-Darwinists.
Good God.
Okay, go ahead, man. Go ahead. But she actually, I mean, if you want me to read it, she's very anti.
Am I going to go on or are you going to keep talking?
Go ahead.
Anyways, so she proposed endosymbiosis, which would have been one of the steps in how we went from simple to complex life. And lo and behold, through genetic testing and a few other things, her idea about that was confirmed. So if she has some weird philosophical differences or like she just rejects some ideas about Darwinian evolution or whatever, fine, so do all modern biologists because we know things that Darwin didn't know in his time. But she does not reject evolution. She doesn't reject universal common descent or anything like that.
Well, I want to know exactly how do you feel about her statement right here. It says, this is the issue I have with neo-Darwinists, quote unquote, by the way. They teach that what is generating novelty is the accumulation of random mutations in DNA in a direction set by natural. Well, Planet Peterson, honestly, what is your actual observational theory of evolution? I don't understand it. Like, for example, when somebody came up with a theory of gravity, we were able to...
You asked a question and now you're giving a sermon. Can you shut up?
Okay, go ahead. Give us this observational...
Genetics in the fossil record.
Everywhere around us, please.
Goodbye. Genetics in the fossil record. Thank you.
Answer that, please. I'll go.
Thank you for coming up, Manar.
Genetics in the fossil record. Thank you. Goodbye.
All right. And then there was a question for you, Planet Peterson, that they say is totally related. But how do you know you're not braining a vat?
That has nothing to do with evolution. Thank you.
Thank you. And then I know Jail Warren had a question in the side chat over there. Since he's in the audience, I'll just pull him up and see if he wants to ask it. Looked like you had a question for both of our guests, Jail.
Can you hear me?
Yes.
Yep.
Yeah, sorry, I was on push to talk. So yeah, I did. I'm not on the YouTube. I'm on the Discord. So give me a second. So I would like Eric. I would like Planet Peterson to chime in on this as well. But predominantly it's for MadeByJimbob. So if evolution, which is defined as the observed repetition of alleles in a population over time as a result of selection pressures, if that is false, then how does the gene sequencing of CTVT, which is canine transmissible venereal tumor, which is a transmissible parasitic cancer, show it being directly related to the Canis genus?
You're saying that if animals don't come from other animals, why do they share the same, what was that technical thing you referred to?
So because we understanding what evolution is and understanding that if evolution are true, then common descent amongst organisms is something that we would expect to see as we see further diversification as a result of selection pressures, whether they be positive or negative selection pressures. But we would see that common descent. Now we have the Canis genus, which is everything that is canid. Okay, that would be everything from wolves to the Chihuahua or whatever.
Yeah.
So we have the Canis genus, and we see through direct genetic sequencing of those genomes of both the Canis genus and CTVT, which is a parasitic cancer, a transmissible parasitic cancer, that itself is also related to canids. It itself is a dog because its DNA genome is canid. So how, if that's what we would expect to see if evolution is true, but if it's false, then why do we see that?
Well, the question is, it sounds like you're taking a category of an animal that's in the same category, and you're isolating something that's found in the organisms and populations of that category, and you're asking if evolution, which assumes the grand category at some point wasn't itself and became that category, why is it that this cancer exists in the category of in the same category? So if evolution wasn't true, how is it that humans only have Down syndrome is basically your question.
No, that's not my question at all.
So how is it, what do you mean? Asking me how is it the case if not evolution's true? It doesn't really sound like an argument for evolution. It sounds like
there are many there are many parasitic organisms that subsist off specific species that literally it's a parasitic relationship they have with them. So like there are just specific organisms. Okay, they target a specific species because that's what they've evolved to do. Now that's assuming evolution. But what I'm saying is that I'm not saying it's like if we like tested dog fleas and they don't share, they're a parasite that subsists on dogs, but we don't see that they're related to dogs, similar to CTVT is, which specifically is a version of a dog that what is estimated to be around 14,000 years ago branched off and became the parasitic cancer that it is today. So it's a parasite that subsists within the dog population that itself, once we genomed that cancer, was itself its own version of a dog. It's its own type of dog. Okay, but it is a cancer. So that's when we sequence the genome of the cancer. Typically, when you sequence cancers, the cancer itself is a result of the organism that has it because it's its own cells working against it, so the genomes will match. But we sequence the genome of this, and we see it's an entirely another version of a dog that subsists as a parasitic cancer that transmits through the dog population. Now, if evolution, which predicts that we will see common descent, that these things are descended from through selection pressures. If evolution is false, why do we see that relation between these two organisms?
Yeah, I wouldn't need to provide an alternative to demonstrate that evolution doesn't make its way through the scientific method. You even used natural or common descent. Peterson used common descent as the cause. You are using this as evidence of common descent. You guys have to decide what your independent variable is.
Yeah, that's not how it works. I figured you would understand it. If Eric wants to chime in on this, I'd love to hear his thoughts.
Saying if what I believe isn't true, you tell me an explanation of what it is. And that's actually not how science works, let alone philosophy.
I got all day.
Good.
Anyways, yeah, I don't really know how to formulate my question, right? We went over like so much of philosophy of science. in my opinion, I kind of want to focus on what Jim Bob said. Maybe I misunderstood it, so I'm just going to restate it. You said that science is very interested in causation and the why, right? But for me, that's something that can be very easily problematized because science seems to operate in a more provisional manner, right? We don't get like essential, like referring to Kantian philosophy here. We don't really like speak of the noumenal, right? We speak of the phenomenal. We don't really have access to the noumenal. So if we are metaphysically restricted like that, then looking for causes and whys is going to just generally not be very truth apt. Do you get what I mean? Or is that too convoluted?
I kind of understand what you're saying. Are you saying why bother in describing or explaining causal relations if ultimately we can't derive any truth, ultimately, like absolute truth from it? Is that kind of your question?
No. I don't think I'm just a fallibilist, right? I don't think it's futile to try to get a better model or better interaction with reality, even though you don't have absolute truth. It's more so that you, and maybe I'm misunderstanding this, but you said that science is interested in the why of phenomena. But I don't understand science to be that way.
I don't
discussion
I don't know if I used the term why. If I did, I would clarify. What I mean is describing the world as it is one thing. Assuming that it maintains is something we assume before we do science, and science is concerned with explaining causal relationships to some probabilities, to some likelihood, which is an inductive issue itself. So if you're saying, are you kind of saying that, are you pointing to the problem itself, or are you saying, can you ask your question like directly?
No, I don't know how to do that. Sorry.
Okay, I want to know what you mean, but it sounds like a philosophical question, and you're looking at
philosophy of
from
science. Yeah.
Yeah, no, I understand. So it's like, I agree that when we do science, we're actually simultaneously doing philosophy. But if the question is, I'm not really asking why does things happen this way, insofar as there seems to be a regular behavior and a causal relationship. Why would be a teleological question, essentially. We can get into that, but the debate today was more like, when you observe something, is there anything we can observe in the world as a natural phenomenon that we can posit a cause to and actually do an experiment to come to a conclusion about the cause? I'm saying in this debate, if we assume that's possible, experiment is going to be the ultimate arbiter between two said assumed causes as hypotheticals or as hypotheses. But your question is like a deeper philosophical question, I think, right?
The problem is like Thomas Kuhn, right? I don't know how familiar you are with his work, demonstrates that like competing scientific models might both have the same, I mean, we've discussed this, or you guys have, but like people could have the same data, but it could not necessarily lead to the same conclusion, right? So what do you do then? Because you're going to have to find some reliable mechanism. I'm kind of a hardcore social constructivist in that, yeah, Thomas Kuhn was right that like the sociological component, right? Like the culture of the scientist is also really important, right? Which is most evident in, I don't know if you're familiar with this, but the, what's the word in English? In geology, right? You had this like shift of paradigms from this classical notion of like how the continents worked and continental drift or lack of acknowledgement of it really. And then this newer model. And it wasn't like until later that there was evidence for this, right? These were just two competing theories. And so I guess what I'm trying to point out is maybe you have something to say to the notion of how do we deal with the ambiguity of evidence and judgment, right? Because that seems to be like at the essence of this. How do we break this problem apart where I'm pointing to the same thing and you are interpreting it differently, right?
Yeah, I think it's a good question. It's a philosophy question. What you're asking is, when we call things evidence, isn't it the case that we're interpreting evidence through a set of presuppositions and a model of reality? Of course we are. So then it gets to a meta question of like, well, now we have to compare models of reality and paradigms. Obviously, this debate wasn't that. And most of the time, this puts people to sleep, as Peterson is demonstrating. So,
Yeah, my apologies.
Peterson, don't you want to get in on this?
Yeah, speak up. Sorry.
No.
No, right?
No? All right.
I mean, I'm interested in it. It just doesn't seem to be the topic today, but it is
I
something
think
that I think people forgot specifically from, I think I blame the Enlightenment for that we just granted ourselves a bunch of assumptions and they said, we don't need to question these fundamental starting points. Let's just move ahead with just pure rational interpretation of the natural world and the physical world. And I'm not surprised we've mostly ended up in a physicalist dominant philosophical paradigm.
Well, yeah,
Now,
because
I think people are rejecting it,
instrumental value. It has massive instrumental value, but it's a limited paradigm. I'd agree. Anyways, I already took up enough time. I have many more questions, but I should.
Thank you, Ego.
Bye-bye.
All right, next question is from Jim Bob's audience. It's Enchanted Hero. I'm pulling him up. He wants to chat with Peterson for a moment.
Hello.
Hi.
Hello, gentlemen. Yeah, forgive me for my bad mic. I have a question. I would like to posit a hypothetical similar to Jim Bob's, just for you to better understand the reasoning behind experimentation. So we have Portugal, right, in, let's say, 1500s. They have routes to Brazil and to India. One route goes to Brazil. On this ship, they have tons of fruits, everything. And people, when they get back to Portugal, they don't have scurvy. Now, the second route goes to India. They have tons of jerky, they have tons of meat and spices, and for some reason they have scurvy. You just have this data. Can you, without an experiment, conclude why one route, right, ships from one route have scurvy and the other route does not?
Yeah, you could literally look at the historical record of all the other ships, which is not you doing an experiment. Like the Big Bang, for example, we didn't do experiments to find the cosmic microwave background radiation or anything like that. What we did was we made predictions and then we found the predictive data in nature absent an experiment. It's possible to confirm a hypothesis that way. An experiment isn't the only way. I'm not advocating for experiments. I'm just telling you that it's not the way that, or the only way, I guess I should say, that you would do that.
Isn't that just
But that
added
is
data,
for-
though? All right, you go ahead. Sorry.
Yeah,
I don't know if
that
we're
is
supposed
for
to
a
jump in.
that is for a hypothesis. But here we're trying to get to a theory. You said yourself it's a hypothesis without an experiment. That's correct. But for a theory, you need an experiment.
What Big Bang experiments are there?
There are none.
It's called the Big Bang Theory. Thanks. Next guess.
I mean, it is called that, but it doesn't
Yeah,
have to
there
be
we go.
one.
It's a scientific theory absent any experiments. Next guest.
Oh, I thought you were like about ending animal cruelty. I was like, what?
But I was going to ask, like, how do you determine like what's true and what exists without the scientific method? Like, how do you go about that, Jim Bob?
Well, did we determine what's true and what exists before the scientific method was formulated?
I have no idea. It's a question
Well,
for
we
you,
did.
though.
Yeah, the fact that we did, I mean, what I'm saying is that the scientific method is about causal relations and basically crafting a scientific theory is making a statement about what causes why. To even do the scientific method, you need to already assume that we can call things and they have categories and there's regularity of nature and there's people with minds and communication. So if you're asking how is it you can come to any truth statements without the scientific method, I would argue that the scientific method being after the fact we've developed language and names of things and understanding a little bit about the world just inductively, the fact that we have induction allows us to then do science. So induction is my answer. You can do induction to high likelihood regularity of nature to engage with the world. And Peterson, you could chime in too. Do you think that we can't know anything about the world unless we do the scientific, a direct, specific scientific experiment?
Like with regard to the natural world, no, you don't. Like, you don't necessarily have to do science. Like, for example, another example I usually give when we're having these arguments about like experiment or no experiment, if you wanted to know something about animal behavior, you actually probably wouldn't want to do an experiment, because we know that animals behave differently in captivity. So you'd want to merely go out and observe them in nature. But I wouldn't say that you're not doing science and that you're not increasing your knowledge on whatever ideas we have about animal behavior, as an example.
If you wanted to broadly call science colloquially just like a body of inductive conclusions about the world, I don't have a problem with that. I'm just saying, when we get into specifically what the scientific method is, it's something that's included in what you'd like to call the umbrella of science, but it's not identical to what Peterson just said and what I just said, just going into the world and being like, oh, that's happening. Like, declaring a statement about the world that's occurring isn't the scientific method. Therefore, we can know things and assume things about the world without a controlled experiment.
Okay. And you keep on mentioning like what is and what's not like the scientific method. Like, what's the like authority you're basing this off of, or where are you getting these definitions?
I would say you can find any definition of the scientific method, and it'll include what I listed in my my opening statement. There's also a tradition of science in regards to its methodology. So I would appeal to tradition, in fact, in this case, and current definitions a little bit. And so when we look at that, I would also argue that for something to really go through a method, you'd actually have to name some bullet points and constituents of that method. Otherwise, what are you pointing to as a method? If it could be anything, then there's a plurality of the method. If there's a plurality of the method, then anything could be a method. Well, obviously, we don't all agree that there's a plurality of the scientific method. It has to have some core components. And these, I would argue, are necessary components. Observation would be necessary. A question about the observation is necessary. A hypothesis inserting the cause of the phenomenon, I would argue, is necessary. Experimenting, introducing that cause, removing, is necessary. Repeating it, in fact, would be necessary, because what if it just happened once? Well, if it didn't happen the same way, using the same variables? Well, you got to repeat it. Forming a conclusion, an assessment of the post-experiment data, is it necessary? And only then can you develop a proper scientific theory.
Yeah, I do think that's like a contention in like philosophy of science. But what I would also ask is like, besides the question or the proposition at stake, like is evolution a scientific theory? What makes you reject like evolution? Like if you're okay with making like inductive claims.
Well, because I'm not taught if evolution posits itself as a scientific theory, as opposed to just some hunch about the observable universe that may or may have not happened, then that's why I have a problem with it, because science is pretty strict. So ask the question again.
Like what makes you reject evolution? Like if you're okay with having inductive claims.
Because evolution is posited as a scientific theory. There are other reasons I reject the grand scale narrative of evolution. I think it's incoherent for other reasons. But the question today was simply, does it actually make its way through the scientific method? I said no. But other reasons to deny evolution, I think there are even philosophical reasons to deny evolution and this transient state of non. I mean, there's no universals under evolution. Things are always changing. If evolution was true, your own beliefs and reasoning would be downstream from a mechanistic system, in which case everything you thought and everything you thought you came to and everything you were persuading other people to believe would be actually an effect of evolution at some scale, an effect of chemistry that was determined. So in that case, there's an epistemic problem, and that's a good enough reason to reject evolution.
Well, you mentioned like could, right? Like it's not saying that.
Last question.
That is the case. But I'll concede my time. Thank you for your time.
Perfect. Thank you. And then we have Gundersmoot up next, and then I'll bring up Circlebot. And if you guys want one more from Minar, we can do one more from Minar.
Jeez.
All right. Peterson does.
Hey, everybody, can you hear me?
Yeah.
Yes.
Yeah, so I want to talk to Jim Bob a little bit. Hey, Jim Bob, how's it going?
How are you?
So you are a young Earth creationist, correct?
I don't really make a claim about the age. I'm not even certain how to even start pursuing that. I don't think necessarily there's any problem with the view. I'm just also would be agnostic about a 14 billion or whatever the number is at this point age. The concept of
let
age
me
itself.
cut through that then and just ask this: which do you think is more accurate of a statement? The Earth is a few thousand years old, or the Earth is a few billion years old?
I would call that a false dichotomy.
It's really not. It's a really simple question.
Well, the fact that I don't know, I couldn't actually give you an answer.
You don't have to know the exact age to decide which is more accurate between saying the Earth is thousands of years old and the Earth is billions of years old. It's the second one that I think is more accurate, but I don't know the exact age of the Earth. See?
Say accuracy assumes some sort of methodology to determine it, right? Yes or no?
So I'm just looking
Yes or
for
no,
which
dude.
what's
Dude,
your
you're asking me a
opinion?
question about
What is
accuracy,
your
and I'm telling
opinion
you
of which statement is more
Hey,
accurate? The Earth is
if I
thousands
just
of years old, or the Earth
if
is
I just
billions of years old?
if I just told you I don't have a mechanism for accuracy, your question assumes accuracy is already established. I'm telling you,
just asking
I
you to
don't
give
know.
me your opinion.
I don't know what accuracy would mean in regards to this question. Because there's no measurement and you don't even have the answer. If you were so certain here, when you say I think the accuracy is closer to this, I'm telling you from my view, I don't have access to the methodology to provide what you call accuracy. I don't even know what the margins of error would be given that you have a method. You? What's the margin of error? What's the margin of error?
I think you're just trying to dodge my question.
That's a question to you. Ironically, you're just dodging my question. What's the margin of error?
I'm the one asking you a question right
Does
now that you
accuracy-
clearly don't want to answer.
No, your question smuggles in a term called accuracy.
Let's skip past it.
You can't even answer your own question, dude. Get out of here.
The world
You
is.
can't even answer your own
Whatever
question, dude.
age you think the world is,
Cool,
if you
I don't
look
care.
into the world, you
No
see
idea. I have no
uh,
idea.
you see development, right? You see
I have no
geological
idea.
development, biochemical development, astrophysics.
That's cool. I have no idea. Yeah, I don't have an idea. His question is, what's more accurate, a billion trillion or 1,000? I'm telling you, I don't even have the methodology and the margin of error to tell you what's considered accurate or not. And I'm asking, does he? He's just telling a story. And I'm asking, what's the margin of error for the mechanism or the way in which you're determining age is accurate, considering you're using the word accurate? And
Howdy. So my question is related to another question that was already asked. I just want to go ahead and get a little bit more detail. That one, which is about ethical considerations. So my question that follows up is for both of you. Are there ethical considerations when using historical data or data collected by others, generated by previous experiments, natural, which is just people taking logs, or intentional experience otherwise? Of course, the extreme case is with medical cases, illness, poison, disease. I understand that neither of you are professionals, so don't feel like heated to go ahead and answer this professionally, and don't feel pressured to go ahead and answer it any way that you don't feel comfortable with. So that's my question.
what's the question? I don't think you formulated a clear question for Peterson or me.
My bad. Are there ethical considerations when using historical data?
I would argue, well, Peterson, I talked for a bit. You can answer this one. I'll answer it after if you want. Yeah, I'm glad you answered that because I wasn't sure if he was asking like a meta-ethical question, like, ought we pursue scientific truth altogether, versus are there things that are justified doing that in the short term look horrendous, but in the utility sense produce something that's worth the sacrifice? Yeah, I think those are ethical concerns for most people. It's rare that I meet someone who just bites every bullet of utilitarianism. But I would actually challenge utilitarianism because even if you assume that approach, it has a type of assumed knowledge of outcome while you make the choice, and we actually don't know the outcome of much. We just assume it. If I do this, a bunch of people don't die, right? That's kind of the method. And I'm saying in science, you do have to have consideration of things that are extra science. I mean, outside of science, because the scientific method itself doesn't tell you what things to avoid or how you should use science. The same way Peterson said, data doesn't tell you how to use it goodly, right? It doesn't tell us these things. So you do have this paired philosophical assumption when you pursue truth. Even Peterson saying I think we ought to pursue or know the truth is a statement that's outside of the scientific paradigm itself, which basically expands the question of science to a larger sphere of thinking, which I welcome.
All right. Well, I thank you each for providing your own answer, and that's it for me. Thank you for having me.
Peterson does.
I'm all for it. Yeah.
Sorry, 1,000 windows open. So on the text questions, is there a scientific theory, Jimbob, that you believe in? And if so, what makes that theory a theory and not evolution?
Yeah, there's tons. I mean, things that aren't ordinarily brought to the surface of the zeitgeist and articles. I brought one up. What causes scurvy? I mean, that's a scientific theory. What causes this? What causes that? Like ailments in the body. All of these theories that are tested and demonstrated through introduction of the cause to the body and removal of the cause to the body. These are all scientific theories I accept. Why? Because they're at the tail end of an experiment.
Gotcha. And then another person asked, if the Bible didn't exist, would you believe, Jimbob, would you believe in evolution being a reputable theory?
I have no idea, because that's basically asking me to deny my own identity and how I would interpret evolution altogether. So it's like asking someone, if you were a carrot, would you still do this? Or if I was Planet Peterson, right? Like, would I think something else? I mean, the hypothetical requires me to not exist in the way that I do. But if there was no Bible and they posited if we still had science, proper science, and there was no Bible, and there was no religion, there was an island that you were trying to teach evolution and you were using the scientific method, I would still reject it if I had access to the scientific method. For sure. I would still go, well, this isn't a scientific theory. It doesn't pass the test.
Gotcha. Then another person was asking, and once again for Jimbob, do you think that, or do you know if the general theory of relativity needed experiments?
Yeah, I also don't think relativity, if you're referring to bending of space-time, causes an effect that's observable in objects. Again, the same problem with evolution is that you can't introduce space-time and remove it to say it's causal. You can't even look at a thing called space-time as an object or a collection of objects or a material itself, because that's reifying space-time. That's saying that space-time itself has physical properties. We say, what are they? And there's silence. So no, bendy space-time, I totally accept that objects have behaviors. If you drop things, it falls. That's a behavior. I totally accept all of the repeatable, observable behaviors we see with objects. The question of what's causing that behavior is a question of natural science. If you don't have access to the cause, whether it's pink unicorns or bendy space-time, if you can't repeat the bending of space-time causally to produce this effect, you're not doing science. You're just doing like sort of like theorizing. You're just kind of like, you're doing poetry, essentially. You're doing philosophy. You're like, oh, this is happening. You're just describing what you think is occurring. Well, that's not, I'm not interested in describing what you think is occurring. I want you to isolate what is actually causing the thing. That's what science is.
Gotcha. And we'll do one more question, and then we'll move on to Minar. They were asking, do you consider creation as a scientific theory?
No.
No, okay. And then we'll go ahead and pull up Minar now.
Oh, man.
One of my favorite debaters.
Hello. Can you guys hear me?
Unfortunately.
Hello. Welcome to the show. What's up, everybody? Hey. Anyways, so Planet Peterson, I'm so sorry. I have a song I made for your funeral. Do you want to hear it?
Yeah.
Anyways, so here's the question, Planet Peterson.
You're not allowed to play music, Minar.
No, JimBob, do you agree with me? Basically, because the question earlier, what you did. Yeah, I that's the only song I know. I wrote it after my ex left me. Anyways, so this is the thing. I want to know, JimBob, do you agree with me that evolution, basically the reason, I think you like some sciences. There's a lot of sciences that you like, because earlier the question was asking you, do you agree with anything to be a scientific theory? Basically, I think what me and you, and maybe we can agree on this, is as long as something doesn't drastically affect the real materialistic world, when it changes the scientific, when the scientific outcome or the conclusion of the theory changes completely, then I think that's why we don't even agree that it's actually categorically science. Do you agree with me there?
No.
For example,
no, I don't agree. I think that what science is likelihood statements derived from induction and experiment, and those are very useful. What you're saying is, if there's a new variable that completely changes the theory, that's actually the value of science, is that a theory could be running for 1,000 years potentially.
But some values, if they change, they drastically change the outcome, and so everything has to change. For example, the crane, if you change the actual trajectory or you add an extra inch to the geometry of it, you have to completely reorganize the equation. It's extremely detrimental to the crane's actual geometry. But so that's actual science. Whereas, for example, the evolutionary science, where every 3 years a new evolutionary theorist is going to come up and say, oh, the new Darwinist was BS. Oh, the new third way evolution is the way now. Oh, maybe we agree with the creationists and everything except that God's not a scientific theory, blah, blah, blah. So you see what I mean? But that doesn't detrimentally affect the world in any way. So is that actual science?
What's your question?
Yeah, you said you had a question for me.
Oh, good. Thank you.
So what do you think, JimBob?
I think there are different fields, like engineering can use science, but engineering can be done without doing the scientific method. If you merge them, you get cooler results and stuff. But in regards
I'm saying we come up with engineering using correct science, but that's science. Evolutionary science is not science, and this is what Planet Peterson needs to contend with. Evolutionary science can change theories every 3 months, and nothing detrimentally can affect the world. So that means this is not something even maybe worthy of us to even look into. So that means it's not even scientific. You see, this is my argument here.
I'm gonna actually try to steel man Peterson, because you put him to sleep here. I would say that if the evolution proponent included genetics in their theory, they can parse out genetics and they can prove you wrong by saying, well, we can do genetic modification in real time and affect things in the world. So I think even Peterson would disagree with you that you can't at least go into the assumed general field of what's called evolutionary biology and mess with genetics and cause a result. You could cause havoc, in fact. So there, I answered for Peterson.
What do
so
you think, Planet Peterson? Why is evolution
Evolutionary
something even worthy of studying?
Evolutionary science predicted insecticide resistant bugs and herbicidal resistant weeds and antibiotic resistant bacteria. And that is a problem that we have to contend with in the world. And so, no, it actually does have meaningful impacts on the world, and it gives us the steps necessary for what to consider in the future and how to deal with those types of problems.
So how do you contend with, like, for example, the third wave evolutionist, which is that's who you are, right? You're not a neo-Darwinist?
I've never heard of a third wave evolutionist, so
Basically, they say we're not creationists, but they say we're not neo-Darwinists either, because that's the only other way you have.
I'll be whatever you want me to be, Daddy. What's your question?
So how do you explain you existing then and the neo-Darwinists being completely inaccurate according to you?
Sperm fertilized an egg.
Yeah, but how can you say, oh my God, we came up with all these amazing conclusions?
You presented
The
it to me,
neo-Darwinists,
and now I can sleep easy at night. Not quite, but
Oh.
oh man.
Still don't believe in praying for people?
Okay, next up, I'll bring up Coolest Dude.
It is the coolest dude. Mute, dude.
He's not muted. He's just
chilling. Well, that's what a coolest dude would do.
He's just a chill guy.
Look at him. Look at him.
I'm looking at him.
Either's fine with me. And Peterson.
Yeah, I don't care. I mean, I don't think any of them are going to be for me, so I don't really have an incentive to stick around. We have to have the guitar off, though, at some point here. I hope so. I've been twiddling my thumbs for the better part of an hour now.
Hello? Can you hear me?
Yep.
Yes, so question for Planet Peterson. So what do you think of the theories that we had before the consensus, so-called consensus, kind of settled on Darwinism and common descent, etc.? Because obviously there were many theories, some of them rather advanced, among people who did not believe in common descent, or people who did not believe in some sense, even remotely similar to modern Darwinism. So, for example, Louis Agassiz and, to some extent, Richard Owen and Cuvier, Geoffroy, etc. So,
I know that the Lord Baron Cuvier and Richard Owen, they were really hostile to evolution. Mostly because they just kind of found it insulting, the idea that humans were the product of it. I don't know specifically what they held to, though. If they were like great chain of being, special independent creationists, a chain of being, or whatever. It's like, okay, do you have any evidence? No, then I'm not interested. So if you could be more specific, I could give you.
Yeah, as a matter of fact, they did not believe in spontaneous generation. Well, maybe they did believe in spontaneous generation, but I'm talking about the explanations for fossil records, for example. Right?
Pierre, when you're talking, could you please slow down just a little bit, please?
Oh, sorry. Yeah. So I'm talking specifically. So the example I want to bring up is the explanations and models of common descent that they had, right? So, for example, specifically for Tiktaalik, for example, that you mentioned as a prediction of evolutionary theory, right? So in a book, in a book called, let me have a look. So Identifying Future-Proof Science. So I've not read the entirety of it, but it makes the case. It is by Peter Vickers from Durham University. He's philosopher of science. So it makes the case that the prediction of Tiktaalik, for example, could have been made in 19th century before Darwin, before common descent, based purely on the models that they had at the time, because they already knew about a succession in the fossil record. They already knew about like some say ecological relationships. So some ecological correlations between things in there. So
okay.
Yep.
Okay, that's a fair point. I would say multiple things. One thing I would say is they could have, but they never did. So is there actually any, like, if all you can do is post hoc rationalization, then does your explanation have any explanatory power? No. Apart from post hoc rationalizations, the majority of people in Darwin's time that rejected his idea, they had some sort of teleological view of evolution. There's an archetype or like an idealized form that the species are progressing toward. So yeah, they would believe in evolution, but they would believe in this very weird idea of it that like emerging
I don't think
complexity and so on and so forth.
They did not believe in common.
No, we know that this is correct. They wrote extensively about this. It's called orthogenesis. This is well documented and known about. The other thing I would say is, like, for Tiktaalik or whatever, like, yes, you can make the post hoc claim that they could have made that prediction, but that is predicated on so much more than, it's not just the fossil, it's the genetics that confirm the degree of relatedness between organisms as well. What's that?
But, for Tiktaalik specifically, there is no genetics there. I'm sorry.
Yes, I know, but we do know that we have like lobe-finned fishes, for example, and they are more closely related to terrestrial vertebrates than they are to other fish. So that is a direct confirmation of what you would predict based off of the structure of the fossil record and how life is supposed to have progressed to what it is today.
So let's say we have Linnaeus, for example, right? So he was already aware of concepts of homology and all the hierarchy, etc. So contrary to what you are saying, these people did not believe in great chain of being. They already had the tree. They already had the idea of homology. And so do you honestly think that Linnaeus would be surprised if you would tell him that there is some sequence of letters that is the genetic material, and it's more similar in these groups than in more distantly related groups? Because he already
could Linnaeus engage in confirmation bias and retroactively fit those discoveries into
what Linnaeus believed is already enough to predict that you would have more similar genetic code, more similar genetic sequences in what he deemed more related organisms. Because
then why did he not make that prediction? You're retroactively fitting in modern data with somebody else's belief and saying, well,
simply because he
could
didn't
work
have the data,
with
but
that.
the theory,
Yes,
the theory
it could work
the
with
same.
unicorn farts too. Therefore, unicorn farts is equally as valid as evolution,
No,
as whatever Linnaeus believed in.
That's not what I'm saying.
I know it's not what you're saying. It's the equivalent of what you're saying. And you can see how stupid it is when I say it, but you don't see it when you're doing it.
Well, the thing is, so I'm saying that the theory of Linnaeus, for example, can accommodate the data of.
So can unicorn farts.
So what?
I believe that unicorn farts magically makes all the DNA of organisms look the way that it does. There.
So did Linnaeus have a scientific theory or not?
Did Linnaeus come up with a scientific theory? No.
Yeah, did he have a theory of, say, of relationships between different organisms?
What?
All right.
Did he have a theory?
We'll do one more question, and then we need to move on. We do need to get to the conclusions at some point.
Linnaeus knew nothing about genetics, and as far as I am aware, he made absolutely zero predictions about if there is a hereditary molecule or anything like that. Linnaeus also specifically thought that species were immutable, which means they are fixed and they don't change because he was a creationist.
Exactly.
Yeah, so
Exactly.
there's
But he
nothing. There's
had the
nothing about
same tree.
genetics that you can glean from a Linnaean worldview. You can only post
He had
hoc
the same tree
fit
and he
data
had
in there.
ways
Okay,
of
Pierre,
building
we're,
it.
we're
So
not doing debating. I feel like he's answered several questions there. We're not going to go debate indefinitely, right? We do have a couple more people that wanted to come up, or a few more people that wanted to come up. We're going to go through these pretty quick, and then we'll get to the conclusions here. Coolest dude.
It's one of the performances of all time.
Coolest dude, if you'd like, go ahead and send me your question via DM. For some reason, your mic's not working. We'll allow Gundersmoot to get one more question in.
I see Bali, and that person hasn't asked a question yet.
Hey, it's me again. Sorry, I'll try not to spurg out this time. So what I basically want to ask is, Jimbob, you think it's reasonable to say all this development that we see on the planet happened in a few thousand years? What do you think planet Earth is going to look like 500 million years from now? Do you think the environment will look exactly the same? That the array of species will be exactly the same? That there won't be a single new taxon, any new clades of living organisms that don't currently exist whatsoever? Because I think this is absolutely bananas.
Jack Nicholson, what's your question? Just reduce it down. You're getting emotional again.
Do you think that in 500 million years from now, that the environment is not going to undergo any major, massive changes or developments, and that the array of species won't also therefore undergo major, massive taxonomic developments, that there won't be new clades of organisms that don't currently exist whatsoever?
Out of here.
Wow. Weak.
You'd be surprised.
Hello. This question is actually for Peterson. It's more of a rhetorical question. What do you think the main disagreement between you guys are, right? Like, you both are interpreting stuff. What do you think about, like, Jimbob's method? I just wanted, like, a comment on that, because we've had this whole, like, thing for, like, an hour now. You probably have an interpretation.
It's been 2.5 hours, actually.
Yeah.
Good question. I'm not really sure. He's saying that it can't be a theory because it doesn't go through the process of developing into a theory, according to him. But I genuinely don't see how that is. We didn't really get very far into developing that because we were during his cross-examination. What I was trying to do was go through the historical account of how we went from the proposed idea to the supporting evidence to then additional like paradigm shifts, which was genetics, which added to but only confirmed the idea. So I don't see how you can look at the development of evolution through the historical lens and not conclude that it is a scientific theory, that it went through those necessary steps. I mean, I heard like there's no independent variable or whatever. We spent so much time on that, but I don't think that was a valid criticism because, well, I don't want to rehash the entire thing again, but there's predictable evidence that was discovered, but then new evidence was discovered that also confirmed it. So,
right.
Without rambling too much, that's what I
just want to add to that. I would ask a question to Peterson, or someone else could ponder this. Is like, what if the hunch of common descent wasn't the antecedent to then finding all of the stuff? Trying to pretend, obviously it's impossible, trying to pretend that you just discover fossils and similarities. If you didn't have the notion already of common descent and evolution, right? A filter through which to look at these fossils. What I was trying to do, Peterson, is imagine finding a fossil of something that's seemingly old and something that it kind of matches anatomically. What I was trying to get to is, like, without assuming the theory and common and all of these things, I was wondering, how would you then go through the scientific method without assuming that you already had knowledge of what you are assuming the theory is? Because that seems to be what was happening, is you were taking the theory itself and placing it into the second part of the scientific method. But is it possible to just do a hypothetical with me, Planet Peterson, and say, what if you found a fossil and it looked like something that existed today, and you thought they look kind of similar, maybe they're related? How would you go about determining whether or not one's an ancestor of the other without assuming the theory that you've already arrived at, you started with? How would you go about that?
Well, any hypothesis assumes that it's the true account of what's going on. So in a sense, I feel like you're like, if we adopt this, I feel like you have to say all science is like confirmation bias or whatever, because you believe that your hypothesis is true. Now it gets tested, and then hopefully that test can rule it out or confirm it. What I would say is, what has been done is the fossil record. I think like Darwin developed his idea by looking at, he sailed around the world and he looked at nature, and he did look at fossils too, because he found like ground sloths and extinct things in places that don't exist anymore. And he thought, how could that be possible? But if life progresses through stages, then organisms of the past would be different than organisms of the present, whatever. But then what happened is we took that framework, assuming it's true, you put it up to the test. Genetics could have de-verified our idea about evolution, because if there was no relatedness, or if the relatedness correlated like literally not at all with what we supposed based on fossils and anatomical studies and whatever, then that would have been such a huge problem that I actually do predict that the theory of evolution would have been largely just thrown aside, and I don't know what would have played.
I understand what you're saying. I agree with you that science itself, natural science, is in fact affirming the consequent. So I agree with you that you say, like the standard is when it rains, it's wet outside. It's wet outside, therefore it rains. You start with that, but I'm saying my argument entirely rests on the reason we can affirm the consequent in science is because we have an experiment. But without an experiment, I'm not sure how you're going to figure out whether or not what you're affirming is true or not. I'm not sure how else you would do it other than just finding more data, third and fourth premises that just assume the thing that that support the thing that you're trying to argue for. So it's like, it sounds like common descent is the thing you're trying to prove. I agree. That's part of the scientific method. But if you don't have access to common descent as something you could sort of introduce, it sounds like you're just going to keep going to different places and adding more data to your assumption. And I'm asking for, I'm looking for like causality. The other thing about genetics too, which came up in a panel I recently had, is like, from your view, isn't genetics just physical structures? So what if it was the case that genetics, along with like carbon and all these other structures, are just inherently a necessary physical aspect of our bodies and organisms? So if that's the case, saying everything's similar by way of composition, how do you even get around saying that they're related if it's the fact that they're just, everything is made up of similar things? You know what I mean?
All contain carbon. Therefore, I came from a car, or I came from a
that would be a concept,
which has carbon in it, or something.
No, I understand.
But,
you're being.
What's different here is there's a process that genetics and heredity does that we understand, so it is confirmable. But the other thing I wanted to point out, my cat. The other thing I wanted to point out was the affirming the consequent thing. Affirming the consequent is a deductive logical fallacy, because those can, if A then B,
for formal
B therefore A. Yep, that's deductive. Science is inductive, so it's not. I don't think it's the problem that people say it is really for science, because science just does not work that way, and it doesn't deal with absolutes. Deductive arguments guarantee their conclusion, we all agree that science is just about multiplying probabilities, sort of.
Yeah.
So,
No, I
anyways,
agree. I was using that as like an analogy, like we assume you have, like, just like you said, you assume the thing you're trying to prove in your scientific quest, right? So it's right there. Like, you have to assume it to check if it's right. And then the reason that I think it's valid where it's not valid from formal logic to do affirming and consequent is because of the experiment itself. We could actually use induction to be like, okay, well, let's see if the assumption was actually correct that we assumed in premise 2 or section 2 of the scientific method. But I think we agree there. Yeah.
Yeah. But you could also just take any argument that affirms the consequent and just restructure it deductively. It's not even hard to do. Like, you'd say, if evolution is true, then all life on the planet would be related. All life on the planet is related, therefore evolution is true. I just affirmed the consequent. But I could just say universal relatedness is a necessary component of evolution. We find universal relatedness, therefore evolution is true. Like, I think I just made it deductive by doing that. So it's a dumb argument, and it's not an argument that you used. So, like, I'm not accusing you of anything, but I'm just pointing.
Okay.
All right. Thank you for the question, Ego. And then Coolest Dude, I'm just going to read his out because he's having connection problems there, or talking problems or something. So Coolest Dude was asking, if inheritance is the only known mechanism for transferring genes in complex organisms, then what other scientific explanation is there for the presence of shared sequences of genomes, including non-functional sequences, than common descent?
Can you read that again, please? Paco?
Sorry about that. If inheritance is the only known mechanism for transferring genes in complex organisms, then what other scientific explanation is there for the presence of shared sequences of genes, including non-functional sequences, other than common descent?
What other explanation for similar or transfer of similar genes or information in species other than their ancestors passed down the genes?
Correct, including the non-functional ones.
Well, I mean, the question is like JL brought up is you're looking at things in their categories. So that wouldn't even be something that was controversial because you're looking at it essentially in a myopic way by looking at a category like he brought up the canis or whatever, the dog category, the wolf, dog, and these things share some similarities in what they have encoded in their bodies. That's not really controversial because common descent would assume that there was something before that category that produced the wolf category or the canine category itself. So when you say evolution, look at this category of shared genetic sequences, including these problematic mutations or whatever, cancerous things. You're looking at it from a framework like this, which is arbitrary. But evolution, an actual honest evolution proponent like J.F. Gary would say it is true. Species and these arbitrary categories of canis are completely arbitrary. At a wider scale of evolution, guess what? Those categories disappear. You're starting arbitrarily with an umbrella category of dogs or this or that. And evolution posits that there was a time where the dog itself as a category didn't really exist. It came from something else then. So you basically have a nominalistic view of taxonomy, and yet the entire quote theory of evolution assumes the opposite of a nominalist view because you have these universal categories that you essentially have to deny. I mean, the question itself assumes let's only look at evolution through the lens of capturing this one frame of one specific umbrella of species or population. Except your theory assumes that there was a time where that entire umbrella didn't exist or was something else. So you're going to have to then make a claim that before the wolf, the same mutation existed in the non-wolf. Well, where's that? What's that origin story?
Ask a question here.
Yeah.
I think I can get to the spirit of the question in a better and different way. So, Jimbob, let's just assume, well, like, let's just throw evolution out the window. Why do you think that there are genetic similarities between organisms, and why are they nested in hierarchies?
I believe there's genetic similarities in organisms because functionally we would need genetics, which would assume that genetics actually serve a functional purpose in the world, right? So if similarity in function ends up being similarity in information, similarity in structure, carbon or genetics or genes or this, we're all made up of similar things. I would say I would reduce it to similarity in function. So if your question is, well, what else accounts for similarity in function? I would actually argue a teleological argument that there's actually a reason it requires a larger worldview than just naturalism to look at the world and say, it seems to be the case that it's geared toward coherency, functionality, survival, and these kinds of things. And genetics is basically the coding, if you will. I know you guys don't like that term, that instructs the organisms of how to live, what to do, when to multiply, how to react to stimuli, how to adapt, these kinds of things. The code is embedded to response, right?
Yeah,
So
there's a huge problem with that. In that, like, for example, a shark and a whale, or a shark and a dolphin, they are like externally designed to survive very much in the same way, in the same kind of environment. However, the genetic overlap between hippos and dolphins is vastly greater than it is between sharks and dolphins. So that explanation falls apart pretty badly.
No, you used my explanation because you, in your first statement, Peterson, said the code is geared toward survival. Does genetic coding have any direction toward it? Or what? Or no? Does it instruct the animal? Does genetics itself instruct the organism to react or do anything? Does it instruct it to do something?
In large part, yeah. I mean, we know that. Like, you're not. I thought you were going to talk about like guiding, like why their body looks the way it does. Yes, clearly, but yes, behaviorally too, as well.
Okay. Are there phenotypes that look similar, but they're not genetically similar?
Yeah.
Okay. Would you say the explanation for something being phenotypically similar but not genotypically similar is function?
Well, I would say this is a phenomenon called convergent evolution or parallel evolution. The ultimate explanation for that, like, weirdly, in a sense, dumb luck is a big part of it, but selective pressure is one of the main reasons why. So, like, for example, in Australia, there are animals that look and behave exactly like moles, but they're not moles at all because they're marsupials, and a mole is a type of, I think moles are rodents. I'm not 100% sure. But if there's a niche that can be exploited, then any organism that has traits that are favorable toward that niche can, selective pressure can push it to become more and more specialized for that niche.
I understand, but what I'm trying to point to from just the physical perspective, from just strictly the natural perspective, there are things like wings that are phenotypical and they serve a function, right? And there are things that have similar similar phenotypes or anatomy that aren't genotypical, like you said, the mole. But I'm saying that from that view, why is it you look at similar anatomy, but ultimately you look at genes themselves as structures themselves, just smaller structures, but you say they're similar, therefore it means something else, whereas anatomy is just a larger way of looking at physical structures. So isn't it the case from your view that genes themselves are physical structures?
So real fast, we'll get through this. There's no more audience questions, so once we get through this, we'll go ahead and move into the closing so that y'all can go grab lunch or whatever you need to.
Sure. It's kind of a reification fallacy to say that genes are a structure because, like, genes, in one sense, genes are very, very, very nebulous. Now, there are sequences of DNA that directly code for a very specific thing, like for eye color in humans. There's literally just a gene for that. But for the vast majority of traits for organisms, it's a extremely complex symphony of many genes interacting together to produce that trait. So calling the gene a structure kind of falls apart because of how much modification of the sequence of DNA happens between transcription and translation and all this other stuff, and how well that would be the main thing, I think. I don't want to ramble too much.
You see what I'm trying to can you understand from my view what I'm trying to frame is like, what is essentially the meaningful distinction? And I understand you're saying, well, they're actually reification, by the way, so we agree. You mean you're referring to something that's kind of conceptual or not material, and you're assigning it to just strict structures, right? In this case, DNA.
Reification is where you say a complex phenomenon is a real thing, like the economy. Yeah. There isn't an economy that actually does things. The economy is emergent.
So what would the word you'd be using to say that it doesn't really exist in that way? What specifically? Is it gene is it coding, the code part, or is it like what is it specifically you're referring to? The sequences itself is like sort of like a metaphysical claim about the structure, but it's not identical to this. Is that kind of what you're saying?
And to be clear, this was the audience question portion, and we're moving back into an examination. So we'll do this last one since y'all are cool with going back and forth here, and then we'll move into the conclusions.
I think what makes it messy is like gene is a noun, but it's kind of hard to actually pin down. But genetics is more of like a verb. It's a process, whereby things occur, you know? So that's what makes it really complex. But anyways, what I would say to sort of get back, and I think this will wrap this up pretty well, is, well, why is calling a gene different than anatomy? Because a gene is just structure anyways. What I would say is, well, but the anatomy was used to make the prediction about genetic composition, like what are our ideas about genetics. And then those ideas came true. So the genes don't stand on themselves as this independent thing that could be whatever. It was a prediction of this other stuff that brought in that.
Okay.
Perfect.
What's next?
So we'll go ahead and go into the conclusions here. These are going to be 5 minutes each. Let me set a timer for that real fast. Peterson, you're going to go first, or Eric, and then JimBob after that. JimBob's going to be closing out the debate here. Let me know when you're ready, and I'll go ahead and start the timer.
You can start it, but I'm definitely not ready. I didn't write a closing. I typically don't really say much with regard to closing statements because I just try to let the discussion kind of stand on its own. But is evolution a scientific theory? I remain convinced that it is, and what I think the shortcoming on JimBob's side here was I never saw, or I never got any kind of description or anything that shows how the methodological approach that developed the evolutionary theory, as we call it today, I kind of lost my train of thought here. I never saw how the methodological approach for evolution was somehow fundamentally different than any other accepted scientific theory, and why evolution doesn't count. Another thing I would say, and this is not a bandwagon fallacy or an appeal to authority or anything, but what I think a very thorny question would be, why is it that virtually every evolutionary scientist, and also like for the most part every scientist, doesn't hold this view? That would be kind of another thing I think that's pretty powerful and would be difficult to overcome. Anyways, so that's my very crappy 1 minute closing statement.
That it? 1 minute you gave us?
No, that's
you
have
like,
5.
wow.
I'm just saying mine sucks because I didn't prepare one. So
no worries.
Well, that's great. And JimBob, I'm going to go ahead and start the timer now.
All right, thank you. Yeah, well, first of all, thanks Taco for organizing this. You were an excellent moderator, by the way. And thanks Peterson for coming on. Yeah, I would say that I'm holding to my original statement that the scientific method is pretty rigorous, and developing scientific theories in natural science requires these key components: observation, question, what causes X, experiment, introduce X, remove X, do it again, figure out what is causing this phenomenon such that we can construct a scientific theory that can be in place and be refuted in the future. The importance and value of the scientific method in regards to natural science is the fact that a theory can be completely refuted. There are potentially unknown variables. So it could be the case, given that we talked about scurvy, that everything we know about causes scurvy is actually more granular than we thought. That is to say, it wasn't actually the vegetables or the oranges, it was some other thing connected to some other enzyme or whatever that we're introducing and causing this effect. This is extremely valuable. Now, does it get us to truth? It actually doesn't. It gets us to likelihood. Now, the question of what a fact is and what a theory is was important at the beginning of this debate because facts themselves are statements about the world. We can use induction to state facts. We can use language we agree on to symbolize those objects. And but that's totally different than the scientific method. I think what I demonstrated here, which is key to those listening who want to attempt to refute evolution and put people on the spot, is simply ask them to go with one observation and try to take yourself down the bullet points of a scientific experiment, the scientific method. Almost every time I've ever done it, probably about 20 times now, it's pretty much at the second bullet point, the hypothesis, I should say, where people get in trouble and they introduce something to the scientific method that they don't have access to introducing or removing, which then forces them, like Peterson demonstrated, into defending that a scientific theory can be produced without an experiment. This is where things get into real trouble, real pseudoscience. That's when I went back to scurvy, and what happened was, well, ultimately, if we're going to determine the difference, the arbiter for two competing hypotheses, it can't be more data, as Peterson said. That's just more hypothesis available. The only arbiter for two competing hypotheses in natural science is an experiment. You knew this. What happened over the last 100 years is we've replaced experiments for models. We've replaced experiments for simulations. This is why we're dealing with a huge generation of people who think science doesn't require the scientific method now. And with that, I will continue to argue against evolution as a scientific theory. I'm totally fine with you having your own creation origin myth. That's fine. That could be argued in varied ways. But if you're going to go around saying something's a scientific theory, I'm going to hold you rigorous to the scientific method because I'm not a science denier.
Are you done there?
Yes, sir.
Perfect. Thank you so much to our guests for being here today. We really appreciate both of y'all being here. Everybody in the audiences, make sure you join Politics Discord. If you enjoyed what Peterson or Eric was saying, go to Planet Peterson on YouTube. If you enjoyed what Jimbob was saying, make sure to follow him too. He's MadeByJimbob on YouTube. And obviously, discord.com/GG or discord.com/GG. I'm sorry, I cannot speak today. Discord.gg/politics is a link to join the Politics Discord. If you would like to have a debate in the future, go ahead and send me a DM and we'd love to get something scheduled. I don't have a fair way to for the audience to determine a winner here because obviously we could have you in your audience, Jimbob, do a poll. I could do one in my audience. I feel like both of our audiences might be biased, so we'll let the audiences decide on their ends who the winner was. Feel free to comment on any of the videos that are posted. I also know Planet Peterson's going to be posting his video here in the next day or so, and so we'll be able to see the comments and go back and forth on that. Do y'all want to say anything to the audiences before we head out for the day?
No, I would just say to Peterson's audience, you're always welcome on my channel. I'm very animated, aggressive, arrogant, but I mean no ill will ever, even with my rhetoric. And you're welcome because I do open up my Discord for debates and discussions like this. And so you're all welcome there if you want.
Cool. And Eric?
But what about the guitar off?
Oh, yeah, we can do the guitar off.
I'm going to concede to your soloing. I've seen you rip. I'm not a good soloist. I'm a Travis picker. So I'm going to have to give you the win.
I don't know how to Travis pick, so that stuff's cool.
Yeah, it is. It's awesome. It's a lot of retraining your muscles. It's a lot of curse words, dude.
Yeah.
Cool. Do either of y'all have anything else, or y'all ready to get out of here for the day?
Nope, that's
I guess
it.
not.
We did
Cool.
3 hours.
Yep.
So
Thank you so much for your time, guys. It was a really fun debate. I know it got a little bit heated with some of the guests that came up, but I appreciate you, especially Minar. Minar's always fun.
Minar.
But thank you, everyone, for being here. And I'm going to go ahead and turn off my stream here, and I'll go ahead and close out the event. If anybody wants to debate in the future, we'd love to do more of these debates on Politics Discord. Feel free to send me a DM on just YouTube or Discord, or message on YouTube on one of my comment on something. I'd be happy to get in touch with you. Right.